guest to evening on our platform. Thank you, sir. Thank you. Over to Pawan Sharma ji. Over to
Today is pi approximation day, sir. So pi can be related with statistics more. So I have related with the AYUSH research, biostatistics for AYUSH research. And really, I am thankful to all the speakers again. And without wasting much time, before starting and before requesting Dr. Korele ji for introducing Dr. Rajput ji again, I would like to request Dr. C.V. Jha sir for his initial words. He is legendary Rasashastri, conducted various research in BHU, and then initial few words from Dr. Rampal Somani ji. He is also legendary expert on the issue. So welcome, sir.
So my namaskar to all of you.
Hari Om, sir.
And I welcome all the learned speakers, those who will going to present their views on the topic. Actually, today's topic is very relevant with the time. Biostatistics, application of biostatistics in AYUSH field. Actually, the time is जैसा हम सभी देख रहे हैं कि साइंटिफिक प्रेजेंटेशन और साइंटिफिक वैलिडेशन इन सब की इस समय एकदम बहुत ही आवश्यकता है। अन्यथा जितनी भी हम बातें करते हैं आयुर्वेद की जो भी क्षमता है तो वो किसी कहानियों की तरह से लोगों को लगता है। वास्तव में जब तक हम उसको स्टैटिस्टिकली लोगों के सामने ना रखें, प्रेजेंट करें, तब तक उस पर विश्वास जमना आसान नहीं है। तो साइंटिफिक टच देने के लिए इसकी बड़ी आवश्यकता है और अच्छा लगेगा मुझे सुनना। और इन्हीं शब्दों के साथ मैं कार्यक्रम को आगे बढ़ाने के लिए आग्रह करता हूँ। धन्यवाद।
धन्यवाद सर। आदरणीय डॉक्टर रामपाल सोमानी जी, आपसे प्रार्थना है आपके इनिशियल उद्बोधन के लिए। स्वागतम। Kindly unmute yourself, sir. Your audio is mute. आपका दो शब्दों में आशीर्वाद इस कार्यक्रम को शुरुआत करने के लिए बड़ा उचित होगा। डॉक्टर रामपाल
सर आपका माइक म्यूट है, उसको अनम्यूट कर लीजिए एक बार।
सोमानी जी सर की आवाज नहीं आ रही है।
सर सोमानी सर आप माइक को अनम्यूट कर लीजिए, एक बार पुश करिए फिर छोड़ दीजिए, आपका माइक म्यूट है।
मैं सोमानी जी से पुनः आग्रह कर लूंगा। तो अब स्पीकर्स के बीच में बाधा न बनते हुए, क्योंकि यूट्यूब के व्यूअर्स भी इस कार्यक्रम को देख रहे हैं, तो मैं आशा करता हूं और आग्रह करता हूं राजीव कुरेले जी से, जो स्वयं भी एक फार्मा एक्सपर्ट है और बड़े अच्छे विषय पे इस मंच को उनने अपना आशीर्वाद दिया है। मैं राजीव कुरेले जी से आग्रह करता हूं कि वो इस साइंटिफिक सेशन की शुरुआत कर इंट्रोडक्शन एस.के. राजपूत जी का दें और अपना वक्तव्य रखें।
सर आप सभी को प्रणाम, सादर प्रणाम। आज बड़े ही गर्व और हर्ष का विषय है कि हमारे बीच में एक मॉडर्न फार्माकोलॉजी और टॉक्सिकोलॉजी के जाने पहचाने चिर परिचित, जिनका साइंटिफिक पब्लिकेशन से लेके हम विभिन्न एक्टिविटीज में नाम सारी जगह जाना जाता है, ऐसे हमारे प्रोफेसर S.K. राजपूत जी का मैं स्वागत करना चाहता हूं। आप गुरुकुल कांगड़ी विश्वविद्यालय, जो कि प्राचीन विश्वविद्यालयों में जाना जाता है, आजकल डीम टू बी यूनिवर्सिटी, केंद्रीय सरकार के द्वारा संचालित जो है, और एक बहुत ही ख्याति प्राप्त विश्वविद्यालय है। और सर उसमें प्रोफेसर एंड हेड के पद पर सुशोभित करते हैं। और सर का अगर हम एकेडमिक बात करें तो सर ने बाबू बनारसी दास विश्वविद्यालय से, अपने नेशनल इंस्टीट्यूट ऑफ टेक्नोलॉजी से आपने सर ने बी फार्मा करने के बाद देश के सर्वोच्च फार्माकोलॉजी के संस्थान, फार्मास्यूटिक्स के संस्थान नाइपर से सर ने PhD करी है विद द हाई ग्रेड। और सर का चाहे पेटेंट की बात करें, पब्लिकेशन की बात करें, सर के मोर देन 18 पेटेंट हैं, सर के बुक्स करीब मोर देन 6 to 17 बुक्स हैं, और कई सारे बुक्स में चैप्टर हैं। सर के हाई इंडेक्स पीयर रिव्यू जर्नल में 62 से अधिक पब्लिकेशन है। और सर के ऐसी बहुत सारे दर्जनों ऐसे पैनल हैं, ऐसी कमेटी के रिक्रूटमेंट हैं, चेयर हैं। सर अपने गुरुकुल कांगड़ी विश्वविद्यालय में डायरेक्टर कैंपस रहे हैं अभी। और सर ने जो है मैंने खुद अपनी आंखों से देखा है, 4 साल में इन्होंने गुरुकुल का नक्शा बदल दिया है। तो मतलब जिनके काम से लोग जानते हैं, और चाहे पर्यावरण की बात हो या प्रकृति प्रेमी की बात हो और व्यक्तिगत जीवन की बात हो, सर योगा में भी विभिन्न प्रकार की डिग्री ले रखे हैं। और MT यूनिवर्सिटी में योगा के भी डायरेक्टर रहे हैं। वैसे MT यूनिवर्सिटी में सर इंस्टीट्यूट ऑफ फार्मेसी के डायरेक्टर रहे हैं, इंस्टीट्यूट ऑफ ISM के भी डायरेक्टर रहे हैं। और विभिन्न मोगा से आपने असिस्टेंट प्रोफेसर से करियर शुरू करा। और कह सकता हूँ चाहे एथिकल कमेटी हो, CII है, इसके भी सर प्रेसिडेंट हैं। और सामाजिक कार्यों में, चाहे मतलब खेल का कार्यक्रम हो, मैं देखता हूँ गुरुकुल में जब से सर आए हैं रोज 4-5 बड़े हाई लेवल के प्रोग्राम होते हैं, और कहीं ना कहीं सर ही कोऑर्डिनेटर होते हैं। तो आज इस रूप में सर को जोड़ के मुझे लगता है कि इस संगठन को, इस प्लेटफॉर्म को और ऊर्जा मिलेगी। तो आज मैं बस, क्योंकि सर हमारे PhD में मतलब हमारे गाइड भी हैं, और सर के अंडर में मैं एनिमल ट्रायल कर रहा हूँ। तो मुझे लगता है कि सर के सामने तो मैं बोलूंगा नहीं, सिर्फ मैं एक शुरुआत बताना चाहता हूँ, दिशा देना चाहता हूँ कि आज आयुष में सांख्यिकी की क्या जरूरत है। तो आयुष से सभी जानते हैं, आयुर्वेदा, सिद्धा, यूनानी, और जो है होम्योपैथी, योगा, नेचुरोपैथी, ये अभी 16 रखा और जुड़ गया है, ये आयुष कहलाता है। और स्टेटिक्स कहते हैं सांख्यिकी को, संख्या को। जब भी हम बात करते हैं चिकित्सा में ये औषधि काम करती है, काम नहीं करती है, तो हम ये बात करते हैं, ये लेमैन की बात होती है। जब इसको वैज्ञानिक भाषा बनानी हो तो हमें गणित की जरूरत होती है, हमें संख्या की जरूरत होती है। और संख्या से संबंधित जब हम आंकड़ों के द्वारा, डाटा के द्वारा, चार्ट के द्वारा, काई स्क्वायर वैल्यू के द्वारा, सिग्निफिकेंस वैल्यू के द्वारा, टेबुलेशन के द्वारा, उसकी बारंबारता के द्वारा, उसके डेविएशन स्टैंडर्ड रेंज के द्वारा जब भी हम कोई बात रखते हैं, तो वो डेटा कहलाता है। वो डेटा प्राइमरी सेकेंडरी हो जाता है, और उस डेटा के आधार पर हम जो है अपने रिजल्ट को विश्लेषित करते हैं कि दिस ड्रग इज वर्क 16%, 70%, 80% और 0%, वट एवर, तो जो भी रिजल्ट हो। लेकिन इसमें अच्छा बुरा कुछ नहीं है, ये एक संख्या है। संख्या हमेशा हमारे विज्ञान को जोड़ती है, हमारे विषय को। तो आज आयुर्वेद में इस लोगों की कमी नहीं है, आयुर्वेद में योगों की कमी नहीं है, आयुर्वेद में विद्वानों की कमी नहीं। लेकिन हमारे विश्व के जो ग्लोबल प्लेटफॉर्म है, उसको संख्यात्मक रूप से हमारे जो योग है, हमारे जो क्लिनिकल रिसर्च है, उनको क्वालिटेटिव क्वांटिटेटिव विश्लेषण करने की जरूरत है। आज एनोवा ट्रायल की जरूरत है। जब हम ट्रायल करते हैं तो पता लगा हमने पैरामीटर लिमिटेड कर दिया और एनोवा में नहीं जा पाते हैं, तो हम इस प्लेटफॉर्म पर चीजों को बता नहीं पाते हैं। तो चाहे हम क्लिनिकल रिसर्च की बात करें, प्री क्लिनिकल रिसर्च की बात करें, ड्रग रिसर्च की बात करें, लिटरेचर रिसर्च की बात करें, संख्या किसके अलावा कुछ भी नहीं है। जब हम किसी चीज को संख्या में व्यक्त कर देते हैं, वो विज्ञान बन जाता है। जब विज्ञान बन जाता है, तो महर्षि चरक ने कहा है, विद्या वितर्क विज्ञानम स्मृति तत्परता क्रिया सा षडगुणम ऐते ना असाध्यम ना अति वर्तते। तो विद्या, वितर्क और ज्ञान, और इनके द्वारा जब हम अपनी तत्परता, अपनी क्रिया को, अपनी स्मृति को जब हम निखारते हैं, बनाते हैं, तो मुझे लगता है कि आज सर ने हमें स्टेटिक्स पढ़ाई है, तो आज सर से ही सुनेंगे। और मैं अपना समय भी सर को देना चाहता हूँ। और सर जो है एक परफेक्ट स्पीकर हैं, और सर के कई सारे यूट्यूब चैनल हैं, सर के वीडियो भी हैं। तो मुझे लगता है कि एक हमारे एक बहुत सीनियर फैकल्टी के रूप में सर से हम लोग लाभान्वित होंगे। थैंक यू सर। हमारे बहुत शॉर्ट रिमाइंडर पे सर जुड़े, और आज मैं सर को शेयर भी नहीं कर पाया। मैं दिन भर खुद ही बिजी रहा कई सारे कार्यक्रम में। कल से एक सेमिनार है, उसकी प्रेस वार्ता करानी थी, तो कई सारे काम थे। तो मैंने सर को अभी 5 बजे फोन किया कि सर वो आपका पोस्टर मैं शेयर नहीं कर पाया हूँ, तो इस दृष्टता के लिए क्षमा चाहता हूँ। और हमारे सभी गुरुजनों को मेरा सादर प्रणाम। नमस्कार।
बहुत बहुत धन्यवाद सभी जो भी हम कार्यक्रम के आयोजक हैं। सबसे पहले तो सबको मैं नमन करते हुए, काफी सीनियर फैकल्टीज गुरुजन हमारे बीच में हैं। निश्चित तौर पर मुझे बड़ा अच्छा सा, एकदम एक्साइटेड सा लग रहा हूँ कि 413 आप कंटिन्यूसली सेशन कर रहे हैं, और कहीं ना कहीं हमें भी इस तरह का एक आयोजन करने का मौका मिला था, जिसको हमने नाम दिया था औषधीय पादप महाकुंभ। और 105 दिन सर ये हमने कंटिन्यूसली किया था, और इसमें राजीव कुरेले जी और बहुत सारे आयुर्वेद के जो भी जानकार हैं हमारे साथ जुड़े, और इस सेशन को हमने बखूबी कंडक्ट कराया। सबसे पहले धन्यवाद देना चाहूंगा डॉक्टर पवन शर्मा जी को, प्रोफेसर विनीत अग्नोत्री जी को, डॉक्टर रामपाल, सभी सीनियर झा साहब जो भी हमारे इसमें जुड़े हुए इस प्लेटफॉर्म पे हैं। निश्चित तौर पर ये मैं सेशन राजीव कुरेले जी का ही है, मैं सिर्फ उसमें कुछ जो फ्लेवर है वो कोशिश करूंगा ऐड करने की। दूसरा, आयुष से बड़ा कनेक्ट रहा है। आपको आश्चर्य होगा कि जो मेरा रिसर्च है वो आयुष की सभी विधाओं में पब्लिश्ड है, प्रोजेक्ट्स हैं, और आयुष आयुर्वेद से लेके योग से लेके आपका होम्योपैथी, सिद्धा, यूनानी, सभी में हमने एक ना एक प्रोजेक्ट किया है, और कई सारे साइंटिफिक पब्लिकेशन हमने किए हैं। तो एक हमें सौभाग्य है कि आप जैसे सभी गुरुजन हैं जो हैं, उनसे जुड़ने का मौका मिला, और अपनी जो बेसिक अंडरस्टैंडिंग है उसको थोड़ा सा एक्सपोज किया है हमने, थोड़ा कनेक्ट किया है, थोड़ा लोगों के लिए समझने की कोशिश की है कि साइंस को हम किस तरह से सिंपल बनाएं। और जो हम बात करते हैं डेटा की, जैसे कुरेली जी ने बोला, बहुत सारा बायोस्टैटिस्टिक के बारे में हम लोग बात करते हैं, तो क्यों ना हम इसको इतना सिंप्लीफाई कर दें कि एक लेमैन उसको भी अंडरस्टैंडिंग हो। क्योंकि वो भी, जब हम लोग रिपोर्ट जनरेट करते हैं, कहीं ना कहीं हम लोगों के ऊपर डिपेंडेंट हो जाते हैं, और जो भी वो बोलते हैं, स्टेटिशियन हो या कोई भी हो, हम लोग फॉलो करते हैं। प्रॉब्लम यह है कि जब हम बायोस्टैटिस्टिक स्टडी करने के उपरांत अप्लाई करने की कोशिश करते हैं, तो आप सभी लोग डॉक्टर हैं, तो आप उसको एक इस तरह से समझ लीजिए कि आप वो एक पोस्टमार्टम ही कर रहे हैं। पोस्टमार्टम से आप फेल या मर्डर या डेथ का कॉज जान सकते हैं, लेकिन बचा नहीं सकते। इसी तरह से जो बायोस्टैटिस्टिक स्टडीज हैं, जब हम लोग स्टडी कंडक्ट कर देते हैं, उसके बाद स्टैटिस्टिकल एनालिसिस अप्लाई करना शुरू कर देते हैं, तो वो हमारे लिए कहीं ना कहीं एक पोस्टमार्टम जैसा ही हो जाता है। तो हमारे लिए क्या इंपॉर्टेंट है कि हम इनिशियल परसेप्शन, जब स्टडी के लिए प्लान भी करें, नेचुरली जो 90% वर्क होता है हमारा, वो होता है सेल्फ। जो हम लोग प्लान करते हैं, आइडिया बनाते हैं, क्या एग्जीक्यूट करना है, 90% वहीं पे हो जाता है, लिटरेचर रिव्यू के माध्यम से होता है। मैं अपनी प्रेजेंटेशन शेयर करने के माध्यम से आपको थोड़ा सा और स्पष्ट करने की कोशिश करूंगा कि आप लोग जो है इसको बहुत इजीली ढंग से समझने की कोशिश करेंगे कि किस तरह से हम लोग इस सब्जेक्ट को लेते हैं, और किस तरह से इसको हम लोग सिंप्लीफाई करने की कोशिश करते हैं। ड्रग डिस्कवरी पे हमने कई सारी इसमें बुक्स लिखी हुई हैं, और आई थिंक स्लाइड्स विजुअल हो रही हैं। ओके, ये जो आप देख रहे हैं, हम लोग किस तरह से एक पाथवे, एक फॉलो अप है, जिस तरह से हम लोग जो मॉडर्न मेडिसिन में ड्रग्स मेडिसिन को लेके आते हैं। सिमिलरली टेक्निक्स, टूल्स हैं जो हम लोग अपने आयुर्वेदिक मेडिसिन या आयुष सिस्टम ऑफ मेडिसिन है उसमें अप्लाई करते हैं, पैरामीटर रिकॉर्ड करते हैं, एनालाइज करते हैं और इंटरप्रेट करते हैं। अल्टीमेटली चीजें जो हो रही है वही है। हमें व्हाट वी नीड टू हैव, जस्ट गिव द एविडेंसेस सो दैट कोई इसको रिजेक्ट ना कर पाए। रिजेक्ट ना कर पाए उसके लिए हमें क्या होता है कि जब हम ओपन माइंड रखते हुए डेटा को कलेक्ट करते हैं, और डेटा को इस फॉर्म में कलेक्ट करते हैं कि वो डेटा लोगों के लिए अंडरस्टैंडिंग हो, डेटा ऐसा ना हो कि वो न्यूसेंस क्रिएट करे, क्योंकि आपको पता है नंबर्स जो है they have lot of values, but they also create lot of nuisance. So what we need to do, we have to organize in a systematic way so that whatever we are doing, that should have some conclusion. So what I suggest that whenever any study is done, we should get the meaningful information out of that. Whatever we are collecting, some meaning should be there. And after meaning, we should have some conclusions. Definitely, whenever we make any conclusion, there is chances of error. Means our conclusion might be right, might be wrong. Right? So here in a statistic, we tell that we should have certain certainty, certain percentage of surety to give any conclusion. So whenever these things we make, we have tools and techniques basically that we'll discuss and you will understand. Things are not very difficult. They're very easy and very easily we can understand what happening. Just take example. We understand there are two things which is most important. One is the population, another is the sample. So our target is always for the population. Any preparation, anything, any activity, any strategy we are preparing, our target is for the population. Here population may be selective. Suppose somebody having the diabetes disease. So here population is the diabetes, the people who are having the diabetes symptoms. Similarly, there is sample which represents the population, but numbers is very less. So number is less because whenever we will conduct any study, we can't do on the whole population. Only the census can be done, which requires a lot of resources, time, and energy. But whenever we do the study on the samples, then also somehow we are able to conclude something. So that is called the biostatistic. So whatever parameter we are studying from the population, drive for the sample is called probability. So what we do, we drive the certain parameters when we have the understanding of the population. So probability is the outcomes of the possible event from total event. So here we must understand that we must know all the options or all the events which are going to happen, and in that you can select some that will work for the samples. But in case of biostatistics, reverse is there. We are studying for the samples that numbers is very small, and we are giving the conclusion for the population. So here poverty and biostatistics plays a very important role for making anything, any conclusions. So that is very important. Let's take example how we need to involve in a first instance. First is we need to understand the problem. What is the problem? What formulation you are studying? Why you are studying? So here our focus, our brainstorming should be there. We need to understand that this problem is real, problem is genuine, and problem has the applicability or implications is there. If we understand first and foremost thing is that, then again we have to understand what for this problem is. Kiski problem hai? What is the target population? We need to understand, because whenever we generalize, we take the samples which is not concerned to that particular target population. What it caused the generation of heterogeneous data, and sometimes it does not we does not get any meaningful information out of that. So we need to understand. Here we are just giving the seizures kind of population, epilepsy is there, and target naturally the people who having the epilepsy is the target. So we need to understand what kind of study design we need to take, what kind of samples we need to identify, sample size, what could be there. And naturally, the sample size, whatever we need to take for the study, that should be randomized. And there is a number of approaches available for that, sampling and randomization. And then we have to collect the observation. So after the treatment, whatever we are doing, we have to collect the observation. And believe me that during the collection of observation, one must we doubly ensure that there's the information, whatever we are collecting, should be real, genuine, and should be taken with full care, because there is chances of human error. There's chances of entry error. So whenever these kind of error may happen, we may fall in the data which may cause the misleading information. So here, the whatever the data observation, as Dr. Rajiv Kurele has mentioned, that we get the numbers naturally, and these numbers, one must understand that these numbers should be reliable, and that reliable can be identified only when we do the data mining or we identified the outliers. So foremost and most important thing is that whatever the preparation or whatever the observation we are estimating, we need to understand that observation should be must not have the kind of outliers that could be there number of regions. First, we need to identify whether outlier is there or not. If we are able to identify, then naturally we have to remove it. If we're not able to remove, here there is a very important thing. Sometimes when we removed the outlier, so outlier is not that we need to just remove one value. Naturally, we have to remove candidate itself. So you are removing a candidate which is involved in the study, there is chances your sample size may be less and your study may be invalid. So here we need to understand that if we're not able to remove it, what we can do, we can transform. So we have the opportunity, we have the non-parametric statistical analysis as well. So to utilize that, and while utilizing that, naturally we can remove the errors which may occur. So here, whenever we have the lot of data available with us, and we do the data mining, and we finally get the data which we believe that it does not have the outlier, and then we can summarize the data. And for that summary, we have the central tendency, the people called is like average, and the average only we used to measure mean, median, mode. Number of average available is there. So depending upon the kind of data we are having that we'll discuss, we can utilize that particular averages. And also, which is the most important, which is the key for biostatistical analysis, is the variance. Because if there is no variance, then the things become the fact, and we can doubt on that. So whenever there is a variance, because we are dealing with the biology, we are dealing with the people who itself have the lot of variations. That could be the physiology, that could be the enzyme kinetics, and then you know that we have the tridosa as well. So temperament, lot of parameters is there which affect individuals and the response to the medicine to the individuals. So here variance is the key, and what I used to tell and what I used to teach is the key variance. And using this particular variance, I can tell which kind of statistics need to be applied. Only one parameter. If we understand the variance, and then everything else remain immaterial. So I will focus towards the variance and how we can approach on that. So whenever any study is being done, we have to get the summary. We call this summary statistic, because we are summarizing, just getting the average and also the deviation or variation. Once we get the average and the variation, now it is the very important that now that whether this particular difference arises, the difference is by chance or difference is due to the treatment. So why I'm saying is that whenever we will do any kind of study, we may be comparing with the control, placebo, or any kind of, so we will get one mean out of the control or the reference standard, whatever we can say. Another mean will be you are testing something, that formulation which is utilized from the hundreds, thousands years. You want to compare that, so that average, and you will get that. So now we want to compare that. So when we are comparing, naturally there will be some difference. Well, whether this particular जो difference हमारा आ रहा है, वो difference by chance तो नहीं है, or if difference is there due to cause, means what is intervention you are taking, अगर उसकी वजह से आ रहा है, तो naturally by doing the hypothesis testing, we confidently say that this particular thing is working. So here lies the solution. Whatever is the problem we used to take, and by following these particular steps, we can come for the conclusion. And I just mentioned about that. Whenever we go for the conclusion, there is chances of errors. So we have to either minimize it or either we have to tell this kind of this percentage of error included while concluding this particular kind of inference, driving the inference. So this is the particular stage which is followed in all kind of research, whether you take Ayurvedic research or you can take the homeopathy formulation, or you take the yogic interventions, or even the Siddha formulation, or you take the Unani formulation. If we talk about that data we can get information, whatever we get, we call it data. Data is itself is the plural. So we need to collect the multiple repeats. Sometimes we miss these things. We must have the number of repeats so that we can do any kind of statistical analysis. Another thing is that the most of the times we get the subjective data. So that subjective data need to be transformed into the numerical data. Then only we can process, then only we can do some kind of analysis. If you talk about data, whatever we get, we can categorize in the four, that nominal, ordinal, interval, and interval ratio scales. These kind of data categorization can be done very easily. Another thing is the variables. One variable you are measuring, one variables you are changing. So manipulation in term of you are changing the temperature, you are changing the pH, you are changing the formulation. In formulation itself, you are changing the components, and on changing that particular things, we are getting the responses, variables, or whatever change is happening, so that we can investigate. Here, very interesting thing is that it is not always that we have to perform our own study, then only to conclude. No, lot of studies is available, lot of data is available. So one must understand with a very keen interest, and the exhaustive information is available with us. You can understand that numerous data, numerous studies are happening, but sometimes when investigator have particular kind of interest, his focus is only that. If you talk about the one coronal medicine also, I was just referring that particular article. I was studying the whole article, and one observation was entirely different. That can be discussed separately, and that no author have focused on that particular information, and that is the very, very important. Though I mentioned about these investigator to these kind of things, one must understand that what kind of data we are collecting, what kind of interpretation we are making, that is very important. So you can understand that even the few people get the Nobel Prize only based on the secondary data. Secondary data is what? That is available in form of magazine, in form of journal, literature. So in kind of a lot of information available with us. Like if we talk about the DNA structure, so that is based on the research of others, E equal to mc square, also from the others research and interpretation. When it interestingly presented in that way, it become a highlights. So that way we can also depend upon the secondary data. Lot of senior the scientists also is present on this particular platform. So I believe that a lot of work has been done. One must understand, one take a time and to understand, to drive some very interesting information, so that we can do. In COVID-19, lot of the people who have come up with a lot of strategies which actually worked, and that's why India was the we can say less sufferer, and we have come out of that troublesome time. So this another is the primary data. That data we are going to generate with our own understanding, with our own strategy, so that we can do. Now, whenever we are collecting the primary data, we need to understand what kind of methodology need to be applied, and where are chances of biasness, or where are chances of the information, misinformation may be collected. So whenever we design the questionnaire, whenever we start collecting of data, we must understand that, and that accuracy, then normalcy, and then that these particular reliability understanding can be done. That can be done through the pilot study as well. If you do the pilot study, you'll get some indicators, and based upon that indicators, you can frame for the whole study. So that is the way we can get the collect lot of information observation. When our observation appears like that, and we present somewhere, this does not have any meaning. So what we need to do? We have to present this particular information in such a way that it is not only attract us, also give a information in a glimpse, because we all are busy in our own assignments. So sometimes we get very little time, less time. So by just observing, can we see that what's happening in our study? And if we just primary indication is coming that, okay, it's happening, so we can try something very important. If you see this particular table, if we put data in that way we have presented earlier, if data is presented in this way, it have a lot of meaning, because here we talk about the BMI and where we need to focus towards the lesser side, towards the higher side, which is population should be our target, where we can work on that. And even also when we are presenting the data into the tables, we can accommodate huge data. But one thing which is mostly missing is that in whatever term, whatever way we are presenting the data, we should tell actual meaning of that particular. And suppose we present data in form of number of ways. So here this formula is given. By that way we just define the number of rows, because table must not be like 50 rows or somewhere 3 rows, 2 rows. No, that there should be 5 to 20 rows. You can make, but there is a formula which can easily applied, and that can suggest what kind of table we can take and what kind of data we can put, so that the meaningful information can be put on that particular thing. As you know that our brain processes the images. Our brain, whatever the information, whatever we used to get, that is processed in form of the images. So that's why it is said that the information which is presented in form of the graphs or pictures that have the value 1,000 times more than the text. So even the Napoleon Bonaparte, he used to follow that what he is used to do. The information which we believe that it will come again and again. We believe that again and again, that information will retain very less time. So that's why Napoleon Bonaparte used to tear up that particular page which he used to study. That's why his memory was very, very good. Similarly, our Rishi Muni, what they used to do, they memorize even our Veds and our lot of Sahita, whatever is written material is based upon the memory. Now talk about that the presentation of the information. So many people do mistake in the presentation of data. As I mentioned, one thing is very important, that with your data, you can get the conclusion that, okay, cholesterol level will be that. Suppose A people is there, and you presented that 10% cholesterol is decreases by your treatment. You, by just seeing the data, you must be able to tell that cholesterol level was that and reduced to that particular unit. Exactly that amount should be reflected. Otherwise, now people are transforming data into percentage, into the radian, whatsoever way they can represent, but they forget to put that exact value. So whenever we can transform this kind of data, we must write that, okay, the basic unit, basic value, 100% represent to 136 or whatever thing is there. Another misrepresentation people used to do, that always these axes should be start from the 0. Here we have the histogram. So here you must understand that this term from 0, and these are simply category. So not necessarily they should start from 0. But if we talk about the line diagram, if we talk about the histogram, so there should be starting from 0. If you are not doing that, then we are misrepresenting the data. Now coming to the summary statistic. Now, whatever the information data we used to collect from any kind of treatment level with us, either Ayurvedic, homeopathy, what kind of Ayush medicines we are utilizing. So what we need to understand, we have to summarize these kind of information. Here we are putting a very interesting image. Here I just tell one the line which is used. अरवा जीव कहते हैं कुनबा टुबा, एक बहुत ही हिस्टोरिकल इवेंट है. कि यहाँ पे जो एक रिवर दिखाया गया है, यहाँ पे लोगों को क्या था, पहले जो अंडरस्टैंडिंग थी वो एवरेज की थी, समरी की थी। जैसे जैसे साइंस इवॉल्व हुई, उसी को लोगों ने यूटिलाइज करना शुरू किया, और उसी के यूटिलाइज होने से कुछ मिस हैपनिंग हुई। उसके बाद जो लोगों ने सोचा कि वी नीड टू put another angle of this particular information is the measures of dispersion, means we must understand low, high, means highest depth, lowest. This kind of information is utilized for that particular purpose. So if you talk about the summary statistic, naturally the single value which can represent the whole data is central tendency. So many of us know that what kind of characteristics should be of the central tendency. We must calculate easily, should be robust, should not fluctuate. If we increase or decrease the sampling size, should be from the homogeneous group. Earlier I has mentioned that whenever the heterogeneity increases, then the conclusion, driving the conclusion become little difficult. Naturally, there are a number of ways we can calculate these particular central tendency, and we have the software called the Sigma Plot, SPSS, or Excel Minitab, or number of software are available with us, and most of the things can be done even the Excel. And many people who done statistically manually, they can also drive a conclusion very easily. So there is not a difficult task over that. If we read a book called A Lady Testing Tea, someone, if we get that particular book, if not, then I can offer that A Lady Testing Tea is a very interesting book, and it tells about how the statistic analysis is evolved and how it is utilized, applies on the biomedical sciences. So that way, this is the easy way to calculate mean, median, mode. And basic thing is that we do not have multiple formulas. Only I will tell you very few, one or two formulas only, which tells we solve over all the issues. Here we talk about the dispersion. You know that there is a very important thing. We must understand that only central tendency will not work until and unless we tell our data in form of standard deviation, standard or variation. So whatsoever is there. So here, just try to understand this wonderful thing available with us, that okay, so variance, you know this, there are only three key parameter, xi, x bar, and n. If you understand three things only, you can understand whole statistic, whole biostatistic. I mean, you can, when, what we need to apply, there is nothing to do when to go parametric, when not to go the parametric analysis. What is here is the only three things, xi, x bar, and n. Xi is the observation, whatever we are measuring. X bar is the average of that. N is the sample size. So three things is there. You understand that, then our things will be very easy. So here we can calculate the average. Yes, xi is there. Just sum of all the values and divide with n. You will get the average. So here the degree of freedom, we know that whenever we are selecting anything, so we have the freedom only n-1, because one is sure that will happen. The outcome, one outcome is sure if we have the 5 fingers. Okay, so if we pick 1, 2, 3, last one will be the fix. So that's why degree of freedom is always n-1. If you utilize these particular things, I'll tell you that if xi, we talk about xi only, the observation, we try to understand that this xi observation, if that follows this have the skewness or kurtosis. So skewness, kurtosis is just what the whenever we are putting the data, that should have the normal distribution curve. If normal distribution curve is not, this data is not following normal distribution, then what will follow? It will have the skewness or it will have the kurtosis. Skewness and kurtosis, before telling to that, I will just try to mention that the data which is normally distributed is followed for the parametric test. So which is not normally distributed, that means that data may have the skewness, that data may have kurtosis. So you can easily identify whenever you are plotting that. So you know that normal distribution have the bell-shaped curve. I hope this is available with us. So here just you can see here the bell-shaped curve is there, and if it not there, then that might have the skewness and that might have the kurtosis. In kurtosis, the symmetry is there. Only what is happening is either there is a flatness or either there is a peakness. Why it comes? The flatness comes when we have the more heterogeneous data. मतलब जो हमारा डेटा है, जो हमने कैंडिडेट चुने हैं, उसमें बहुत ज्यादा वेरिएबिलिटी है. तो वहां पे आप अगर देखेंगे कि जो शुगर लेवल है 110 वाला मिल रहा है, 120 वाला मिल रहा है, 300 वाला मिल रहा है, 400 वाला मिल रहा है, तो इस तरह से बहुत ज्यादा हेटेरोजेनिसिटी है. और कुछ डेटा में जहां पे बिल्कुल होमोजेनिसिटी है, वो डेटा बिल्कुल क्लोज इंटरवल, सपोज करो एक डायबिटीज ग्रुप है 190 से लेकर 200, बहुत ज्यादा क्लोज. So that both things are not very good for our understanding or our conclusion. So what must have, we must have the distribution of kind of that. If this distribution is not available naturally, what we need to do, we have to follow this non-parametric. So skewness, kurtosis calculation is very simple. No other formula is required. Only the formula which variance which is required. If you know about the variance, that you can do. Now skewness. So here the formula is just can mention about this is called moment 2. This is moment 2 because here power 2 we are taking. If we take 3 power moment 3, if we take 4 power moment 4. So this is just for the understanding. Skewness we use moment 3 and kurtosis we use moment 4. And if you utilize that, we can easily calculate. If something is coming that shows that this is not normally distributed. If not normally distributed, then there is some issue and that issue can be rectified. If not rectified, then we have to transform that. Now, how we can understand which kind of test we need to apply? Just see this is XI. XI observation is normally distributed. What test we need to apply? Parametric test, t-test, Z, ANOVA. This kind of analysis we need to do. Another thing is that we need to see that sample size. If sample size is less than 30, go for the t-test. Sample size more than 30, go for Z test. If X bar itself, X bar is the average, and average numbers means average number is that we are getting 1 average, we are getting 2 average, we are getting average 3 average, means from a study. That means there is a one group we are getting 1 average, there are 2 average, 2 groups may be there, multiple if we are getting more average, there could be the different number of groups. So we have to follow the ANOVA when numbers are more than 2. So here are very simple tricks, and here we are connected with this particular formula. So if we have the variance, just square root, you will get a standard deviation. Then is whatever you got a standard deviation divided with the root n, you will get a standard error. And for the for this particular confidence interval, the formula is mean average is there plus minus ZSE. Z is the this probability value that we can get from the table. Similarly, the t-test is what? We are just finding the difference between the 2 groups. So what necessary thing is there? The difference between 2 groups means difference in the mean divided by standard error. Here we just see easily difference in the mean and divide with the standard error. You will get the t value, compare it with the tabulated, and you will get the conclusion. Similarly for the Z test, and here if you talk about the chi-square direct formula, this formula is utilized, and this is the most frequently utilized formula for that. Here, just formula is what? Observed minus expected whole square divided by expected, because here chi-square we have to see, means one is the chi-square, I say chi-square count and category. If you know, the observation, whatever we are doing, we are just counting it. And counting what? Out of a category. So here category thing is there, and you are just counting, utilize the chi-square test. And similarly, the ANOVA itself tells analysis of variance. So here what we used to get? We get the ratio. We divide the variance due to interventions. So whatever we talk it, we called it the variance between, means we have A treatment, B treatment, C treatment, or we are just comparing the different AYUSH formulation, Ayurveda, Yoga, Natural, then Siddha or Unani. Just want to compare that. So in that particular thing, that will be the variance between the group. Although English in that particular among must be utilized, but in a statistic we call it between the groups variance divided by the variance due to individuals. जो उस डेटा में पार्टिसिपेट कर रहे हैं उनकी वेरिएंस क्या है. So similarly, any effect which is coming from the, either you take the Ayurvedic medicine or either you take the homeopathy, that particular person is responding maybe because of one thing is that he's taking that medicine. Another could be what? The person's own immunity, person's own response, own body composition, own enzymatic things, right? So here we get the ratio and just calculate that, and we get that particular F value, and that compare it very simply we can do. Another is the correlation studies. Here we try to correlate whether one variable is associated or not. Very important study should be done first. Then we can understand if there is any correlation, and if we are getting a good correlation, we can utilize for that particular thing for the prediction. Means कितने दिन में सही होंगे. एक issue बहुत जो हमारे आई सिस्टम मेडिसिन के साथ एक चैलेंजिंग है, उस पर बहुत काम करने की जरूरत है. वो है टाइम फ्रेम, टाइमलाइन. We can't predict if we follow this particular regimen, the person will respond in that particular time. So here, if we have this strong correlation in one variable to another, if the strong correlation is available, we can do the prediction. And if we do the prediction, naturally, it is not always that we will go right also, but we can have some the duration, some gaps or some interval that can tell, okay, the particular person may respond in this particular time frame. That is very important. And I think this particular research group, that Independent Research Ethics Society, people are doing a great work, and such kind of platform is there. They can help a lot of researchers so that they can establish the time frame. Now, another thing that the outlier, as I mentioned, that very interestingly can be identified. And if you identify the outlier from your study, that occurs whenever we have the kind of the population availability with us, we naturally get the outlier. So then outlier is there, we have to identify their range, and if that need to be removed, we must work on that. If not, then we have to transform in a way that they do not affect or they do not misrepresent or misconclusion for that particular thing. Another, I think, mentioned that descriptive statistic, whatever I told about that, how to describe the things, how to make our data observation meaningful, right? So another thing is that we have to drive the conclusion, and connecting both is the probability. And as I mentioned, that probability is the study of all the happenings, must understand all the outcomes, then we can go for the samples. So here in the biostatistics, we just reverse it, we study the samples and get the conclusion for the population. So here both things is very important, necessary for drawing the any conclusion. So here inferential statistics, what I suggest is that ultimately aim of any study should be the conclusion. This is again a very challenging thing. Whenever we do any study, then also after doing lot study everything, we just say that might happening, that might be that, maybe this, maybe that. That should not be the case. You're doing a lot of study, you must go get some conclusion. Otherwise, you are giving the scope for another study. So at least we should complete a fraction of a study with good amounts of conclusion or recommendation. That should be the key. Here, if we have only one group, then naturally we go for the confidence interval, we says point estimate. So earlier the range value was given highest minus lowest. Now it is the time when we utilize the confidence values with the 95 confidence, 90. Here nothing is changed, just the formula I told, that mean plus minus ZSE. Only the value of Z or T is changed. That is again is available, and that can be identified easily. And when we have two variables, we do not know what is happening with whether they are related or not. What we used to do, we identified their relationship, whether one variable is associated with the another. If we do that particular thing, and again here also we have just use the formula of the variance only. Here variance together, we say variance together and square root of variance individual. So here variance together, dono variable, both the variable taken together, and variance is calculated, and here we square root the variance of individual. And if you do the calculation, very simple thing is there, just the salt intensity and it is increases, naturally the systolic blood pressure is going to increase, and if you calculate, and easily that calculation can be done, and we take the variance together, and then the square root of variance individually, we get the R value. R is the correlation coefficient. Again, another the variable that is very, very important is coefficient of determination, which is utilized, and this is the again tells about that how one factor is affecting the another, and what are the factors which are not directly connected, or they do not have not understood in that particular study. It is the R square. Whenever we plot the standard curve or anything for estimation, naturally we get the R square, and we go for the higher R square values. Higher the values, that tells about that the variation which is coming, because from one variable to another can be explained. They're not like 6-9% coming unexplained. So basically, whenever we are plotting the standard curve, we get the values 0.999 kind of thing. Okay, so here regression again is nothing. We are trying to go for the prediction. So here we are getting the this kind of observation. We can draw a line like that. We can draw an n number of lines available with that. So what must be understood is that the variation, minimum least square deviation, we say LSD, least square deviation. Again, that is deviation, variance only. The formula for the same. So here we take the deviation and we take least deviation, which is coming, all these particular deviation is summed up, and which is coming the last is the regression line, and that regression is utilized for the prediction, which is most important things to do. So formula for that is again not a very difficult thing, because I connected all these formulas only through the variance. So again, this is the R correlation coefficient. This is again the standard deviation. This is you are already understanding standard deviation is nothing but the square root of a variance. So simply we follow only the variance, and we can do any kind of prediction analysis. So here regression can be done, and this is the, I think many people do not utilize this, because regression may be the simple regression, or there could be the multiple when you have the multiple factors, and that kind of study we do, we can closely predict towards the accuracy. So we must follow that. Another thing is, which is the hypothesis testing, which is utilized for that driving the conclusion. And here I just want to mention that a lot of researcher or teacher are here, so they must understand that whenever the synopsis or whatever the research they are trying to do, there is a hypothesis. So the hypothesis that is entirely different from the statistical hypothesis. What I seen many times in the report, the people like the will follow null hypothesis, alternate hypothesis, is that is not the case. First is the working hypothesis, in which you try to stipulate, or you try to mention that why, what do you think, what is what kind of question for your study you are having, and how you understand that your strategy will solve that particular thing. So here the working hypothesis is that, means you have to tell, based upon the information available in kind of literature, that the outcomes you are looking for to solve that particular problem suggested through number of the observation, number of the data or literature available with that. That is the working hypothesis that is utilized. And then statistical hypothesis is entirely different. So in a statistical hypothesis, we assume that both the things, means if we are comparing two groups, we assume that two groups are having the similar values. So we call it null hypothesis, and always our aim is to reject the null hypothesis. Just see here, if anyone have the difficulty to understand that the errors we make. So in hypothesis testing, we just try to drive a conclusion, try to drive an inference. So whenever we're trying to drive an inference or conclusion, we are bound to have some kind of error. So here two kind of error is there. We call this type 1 error, we call this type 2 error. Type 1, when you are rejecting true null hypothesis. For easy, for making things very easy. So similarly, whatever research we used to do, just you can match with the court proceedings. In court, we assume that the person who is coming over there or who brought to the court is not guilty, is innocent. Right? Not, we say that is accused, not convicted. Similarly, in study, we say two groups may be different, but here we assume that null hypothesis that they are similar, because still we do not have lot of information to reject. Similarly, court does not have lot of information to reject the innocency. Similarly, we do not have the lot of information to reject the null hypothesis. So whatever we need to do, we have got lot of data we have to collect, and then we have to reject it. And when we are rejecting true, means null hypothesis true, and we are rejecting is type 1 error, and type 2 error when null hypothesis false and we are not rejecting. Just see the example. The person, the female, suppose you can just, you see this particular picture. You are not pregnant is the doctor is mentioning. Means true thing is that, and they are rejecting the true. So are making the type 1 error. And the false thing is that the male candidate is there and doctor is saying you are pregnant. So that directly indicate thing is false and you are not rejecting. So making type 2 error. Believe me that whenever we do study, type 1, type 2 error, they will remain there. So what we do, we fix the type 1 error. In a statistic term, we say we fix the type 1 error, means rejecting the true, we already fix. Maybe 5%, maybe 1%, or maybe 0.1%. That depend upon the what kind of the study is yours. Another thing is that the type 2 error, not rejecting the false. Simple thing is there. And if we try to minimize one, believe me that another thing will be increased. So just take a scenario that one person is visiting a doctor and having some kind of swelling. If doctor suggests the person is having the tumor or cancer based upon his observation. So and when it goes to the biopsy or diagnosis, it is found that person do not have the cancer. So here true thing, person do not have the tumor or cancer, and doctor is not rejecting. Naturally, the error is happening over there. Another thing could be there, the tumor is there and doctor is rejecting that. So true को reject कर रहे हैं. Type 1 error, more severe. We fix it. We only allow 1%, 0.1%, or maximum 5%. Never 5.5, 5.1, or 6%, right? So in that particular thing, we can fix one error and try to minimize the another. So naturally, there is a very limited option available with us to reduce the type 2 error, which is again a very challenging task. And type 2 error can only be minimized by increasing the sample size. Here, I want to mention one thing more, that sample size. Mostly people ignore that particular thing, and I have seen some of the thesis or synopsis in which we calculate that particular sample size, and sample size when it is coming to use, what we try to mention that due to the lacking of resources, time, or whatever the thing is there, we have reduced sample size to this much. We need not to do that. what we need to do, if we go for that particular thing, understand that the parameter. So there are 4 things which is required for the sample size. One is the difference in the mean. Means what is the gap? If gap is huge, naturally sample size will be less. And if gap is very less, then we require the sample size more to detect the difference. Another thing is the variation. If variation is very less, we require a very less number of people. Variation is huge. Naturally, the sample size will increase. Another is the alpha and beta, that is type 1 error and type 2 error. We used alpha, we can fix at 0.1, we can fix at 1, or we can fix at 5%. So naturally, if we go for lower side alpha, error should be very less, so sample size will be more. Similarly, we used to take the power of the test, in which we use the beta. 1 minus beta is called the power. So whenever we are calculating that, can we utilize 0.9 or 0.8, not less than that. If it's coming less than that, then reliability is decreasing. So somehow our test, whatever we are doing, we should be ensure that what actually we are doing, what kind of error, what we have fixed, and what could be the possibility to decrease the errors and to get the more surety on our the understanding or conclusion. So here just I put some of the t-tests so that the people can understand, because mostly the people utilize the t-test, they compare 2 groups when need to apply paired or unpaired, or even these two-way or one-way ANOVA analysis, or we can say one-tailed, two-tailed. So that kind of thing is very, very important. So one-tailed or two-tailed. Suppose I have one control group and another is the reference or treatment group, and my conclusion may be in difference if come in either side. Means if I say that this particular nutrition or food, right, is changing the weight. So whatever the weight is coming, I say this, if you follow this particular strategy, that will change the weight. What does it mean? Change may be either side, may be lower or higher. What actually our task is, what actually we want. Either side we can, if we can accept that difference, if it's coming either side, and our study will be okay or good. Or we have the limitation that in diabetes, suppose we are talking about sugar levels should go down. But in our study, we do all analysis and we do the significant test, and we get that there is a significant difference when you give the formulation and your outcome is says that there is a significant difference. So what should we take? That significant difference could be either because the diet, whatever you have suggested, had increases. So if it increases, that means the practical significance, the practical applicability, that formulation is not there. So that is remain the one tail. So here we have the different kind of scenario when we have only one group available with this size. Another parameter is population. We have derived from the population. We are just comparing the sample with the population. We get the single mean test. And whenever there is 2 different populations or different groups, different candidates are available with that unpaired t-test. When there is a treatment, when we are taking the before and after we used to do, and the formula for the same is remain the same, difference in mean divided by standard error. But for the pair test, we call it the mean of differences, because we already do the difference, then we take the mean and utilize with the similarly thing like we are utilizing for the t-test. The simple thing is that, and we can do for the t-test a lot. Many people are doing following the t-test. One more thing which we need to understand, that we take the observation sometimes on different time points, means 0 minute or 1 hour, 2 hour, 3 hour kind of thing. So so that way we are utilizing, right? So in that case, we have to take the repeated measures ANOVA. What I will tell you that if we are time point is 3, more than 3, so naturally average number of average is more than 3 we have to go for the ANOVA, but groups are same, they are not changed, these people are not changed, so we have to take the repeated measures ANOVA that can be utilized. Again, after the t-test, chi-square test, I mentioned that is more robust, mostly utilized. Two things only remember, one is the count, another is the category. If you follow that, simple test is available with us and we can apply and go for this particular conclusion. Now, ANOVA, as I mentioned, that this is just the analysis of variance in which we take the ratio, variance between treatment, ratio, variance within the treatment. So that way we get the F value and we can just conclude from the study. One most important, whenever we're doing the ANOVA, naturally number of groups is more. So only what we can do by the test, that there is a significant difference, but we do not get which group differ from what. So we have to do the follow-up test, that that test can be utilized. So one-way ANOVA, two-way ANOVA, multiple-way ANOVA, repeated measures ANOVA, this kind of ANOVA with us. And this, if you follow that ANOVA, we can do that. We can compare multiple the groups study. And lastly, I just will not go more on the non-parametric test. This non-parametric test is utilized when we have this particular observation, either skewed, either kurtosis that does not have the bell-shaped curve, or we do not have the this observation could be distribution free. Means we do not ensure, we are not sure about their distribution, we utilize the non-parametric test. So they are as similar as we utilize for the parametric test. We have the methods available with us and we can do very easily. So here I just lastly I will mention that, as I told you, that I've done the yogic, homeopathy, Ayurvedic, and even the not very much close to Siddha, but naturally there are preparations which is utilized for the minerals. The study we have done and a lot of publication we have done for that. So the people which is go for the non-parametric test should be ensured that there's no scope for utilizing the parametric test, because reliability of the test is more on the parametric than the non-parametric test. So I will thank all the organizers and the Rajiv Kureleji, who was this particular motivator for this particular session. I think I have not taken more time, but naturally I am available on a call. So whenever you want to understand about the statistical software or you have any case study, we can perform live test on that. And definitely whenever time will permit, we can have kind of utilize such kind of platform, because ultimately our aim is to make this great country a global leader. विश्व गुरु हमारा जो है वो आयुर्वेद से आता है, जो जीवन की पद्धतियों को बताता है। आयु हमारी जो है 100 साल तो हम बहुत जमाने से मान के चले आ रहे हैं, हालांकि बीच में बहुत वजह से 66, 64 लाइफ एक्सपेक्टेंसी पे आ गए, अब धीरे धीरे वो बढ़ रहा है। बट हमारे जो भी स्टडीज, जो भी हमारे लिटरेचर है, वो 100 साल से कम की बात ही नहीं करते, और उसमें कहीं ना कहीं योगदान सभी आयुर्वेदिक फिजिशियंस, डॉक्टर्स का है। तो मेरी तरफ से, मैं गुरुकुल की तरफ से आप सभी को धन्यवाद देना चाहूँगा जिन्होंने मुझे अपॉर्चुनिटी दी इस टॉपिक पे बात करने के लिए। बहुत बहुत धन्यवाद। थैंक यू, थैंक यू,
थैंक यू सर, थैंक यू। इट वाज रियली वेरी नॉलेजेबल फॉर अस। और हाँ, एक जो साइंटिफिक जो है कोई भी विज्ञान बनता है तो इसी स्टैटिक्स के आधार पर बनता है, और जिस पे थोड़ा सा हम लोगों का फोकस कम है, तो इसको और ज्यादा कंसंट्रेट करने की जरूरत है, ध्यान देने की जरूरत है। मैं सर का हृदय से धन्यवाद एवं आभार व्यक्त करता हूँ कि सर ने बहुत ही अच्छे तरीके से हम लोगों को ये स्टैटिक्स का जो कठिन विषय है बहुत सरल और बहुत व्यवहारिक और बहुत प्रैक्टिकल तरीके से समझाने की कोशिश करी है। अब मैं पवन शर्मा जी को हैंड ओवर।
बहुत बहुत धन्यवाद साहब आपका। आपने बड़े वाकई में ऐसा मैस्मराइजिंग था कि सुनना इतना सरल लग रहा था कि स्टैटिस्टिक्स दोबारा से सरल होकर हम लोगों के सामने आया हो। मैं अग्निहोत्री जी से उनके कमेंट्स की प्रार्थना करूंगा कुल्लू जी के पहले। आदरणीय वीके अग्निहोत्री।
थैंक यू, नमस्कार डॉक्टर पवन शर्मा जी। डॉक्टर हेमा शेट्टी हैंड रेज किया है, अभी वो
जी
कुछ
सर,
पूछना
मुझे
चाहेंगे?
हाँ जी, मुझे क्वेश्चंस थे सर से थोड़े से, इसलिए
बेटर है
पूछना
आप
चाहती थी।
क्वेश्चन उसमें चैट बॉक्स में डाल दिए, क्योंकि सर ने बहुत टाइम लिया, ऑलमोस्ट 70 मिनट्स कवर किया है। हमारे पास
ओके,
4 और
ओके।
स्पीकर्स हैं, अभी हम इंटरप्शन नहीं चाहेंगे सिवाय अपने दो लाइन कमेंट के बाद। लेट अस सी व्हाट इज योर क्वेश्चन एंड हाउ ही विल गिव द आंसर, so that
Sure,
will
sir,
be
sure. I'll put all the questions in the chat.
that will be a better protocol, I think.
Yeah,
Okay,
okay, sir. Okay.
thank you. So thank you, Professor Rajput sir. What a wonderful speech you delivered, irrespective of the time limit, because when the interest is created, then the time is not of much value. Moreover, Dr. Rajiv Kurele already handed you over his time, so he sacrificed his time. And for me, as you are helping him in his PhD guide, means PhD work, so it itself becomes a matter of honor, because Rajiv Kurele already had touched a lot of heights on his field, and he has participated in our this webinar so many times with a very vital approach. Once I have given the man of the webinar on that day. So when Rajiv Kurele recommended you and you justified, so already honor given, it becomes my pleasure to honor you in that way. Moreover, you touched so deep. What should I say? If I say that the era to which we belong, it's very back. It's 40 years back when we were doing our MD way back in 1980-81. So you see, there was hardly a calculator, nothing doing, no tablet, no computer, and how it is easy, just to click and you will get the pi, the diagram, the everything. And we were having our 2 statisticians there in our department in BHU. They were helping us, and we were simply knowing the knowledge of statistics only up to high school level in mathematics. So t value, p value, standard deviation, and all that, these were the initial things, mean, medium, mode, etc., etc. So for a researcher, important is that what result he is going to give is simply whether it is of significant value or not. That depends upon the p value and t value, what I just remember. But you touched all the things, and the thing which you touched for us is very important. The whole of the Ayurveda is depending upon Sankhya Darshan, propounded by Kapil Muni. You see, Sankhya and Vaisesika is the basic fundamentals of our science. So we were having the medical sciences, medical statistics in our subject, and then we used to tell that you have to collect the data. Data is the vitality of the whole system. So you touched that sector very importantly, that how much patients are available there in cholera in a particular area, or tuberculosis or so. Today also we are enriched with the data filter that India has given plus 200 crore vaccine dose against COVID-19. This is what the database vitality. So our science, as you also understand, line that information again and again. What was the life motto of Napoleon Bonaparte? And here what is? Buddhim Pashyatiyam Bhavan Bhukarma Yogjam. Already Yukti Puran, under the heading of Yukti Puran, again and again, for the confirmation of the information. This is what the basic is. So if you have done something in that way, I think in the sense of Ayurvedic and yoga and naturopathy, you are a great pillar for our studies and to guide our all these data in a nutshell manner, so that we will be in position to project our informations in a form of digital capacity to understand by any of the countrymen, any of the country, not only our India itself. So much thank you. Your work was equally two weeks tutorial to a PhD scholar. What you extended it a 2 weeks tutorial for a PhD scholar. So those who were here and those who will view your all information through YouTube, they will definitely be indebted for you. Thank you so much. Thank you. Over to Dr. Pawan Sharma ji. Pawan Sharma.
Thank you, sir. Thank you very much. Now I would like to request Dr. Arindam Kundu. Dr. Arindam Kundu is a statistics expert of University of Calcutta. He is guiding PG scholars there. He is executive editor of various magazines also. So without wasting much time, I would like to welcome Dr. Arindam Kunduji. Please guide. Thank you, Dr. S.K. Rajput sir, and thank you, Dr. Arindam Kunduji. Welcome.
Thank you, sir. Am I audible, no? Just wait. Am I audible, no? Hello?
Yes, clear.
Okay, yes.
Audible and your slides are visible.
Okay, thank you, sir. So biostatistics covers, there are so many topics like survival analysis, epidemiology, agricultural statistics, clinical trials, and so many things, and quality of life. So there are so many aspects which covers the biostatistics, and also in administration also, medical administration using biostatistics you can do. That covers so many parameters like bed occupancy, then waiting time, discharge waiting time, admission waiting time, etc. Now, for putting a research, there are two things. First, we have to define aims. What is your aims? That should be clearly defined, and objectives has to be clearly defined. And main should be on primary, and rest should be secondary objectives. And primary objectives should be focused on. And so there are then study purposes already. These things, most of the things have been discussed. Dr. Rajput said. So now this is the study design. So there should be study design should be there two things. One is observational and experimental. And observation there are three types. One is cross-section, retrospective, and prospective. There are three types of study designs are there. So, and main thing is that now for this type of study, the allocation of the sample is very much important, and that should be random. It's a main focus that the patient should be allocated randomly. Now, if there is more statistics is standing on the basis of randomness. Okay, so and so I'm not going to sample size because already has been discussed. So now follow-up time is another factor for study review because you are giving a treatment to the patient, and what's the follow-up time? Now, say for chronic patient, it could be, I think, a more the span should be more because to observe the adverse reaction, adverse drug reactions, or the treatment effect, there are chronic and acute type of disease also. There are other disease which takes times for curable. So for curable, so that is there are some disease which takes time. So naturally, depending on that, follow-up time should be that. Yeah? So now the data collection is to be in specific format, and data collection means there should be data collection is in lab-based data, it should be questionnaire-based data, and questionnaire-based data, suppose there are some validated questionnaire, but if there is no validation of the questionnaire, you have to, the questionnaire should be validated based on, there are so many statistical techniques for validation of the questionnaire, like retest reliability, etc. Validity, reliability of data. Because when questionnaire means you are asking the same question to the same individual at different time points in the same identical situation. In that case, the variability of the questions would not be within the range, should be within the range. So that's called retest reliability. So there are so many techniques and tools to validate a question, and also the questions could be in different scaling. There is one Likert scale. There is another type of scale. Likert scale means, say, how do you feel? That is the words. Then it could be that it's okay or okay, but it's not very good, like that. Then good, very good. Then how are satisfied with the service? Say mostly dissatisfied, then dissatisfied, so and so, then satisfied or highly satisfied, like that. There are different. This is called ordinal scale, and these are one type of Likert scale. But these are not continuous data, but there are data to be in a continuous also. So now categorical and everything has been discussed. Now this is what the descriptive plots. Now how do you plot the data? Data can be plotted in bar plot or histogram plot, and other than the box plot. Now you see the box plot, just a minute. See, there is one data for post residual volume data. This is a box plot. Now, what is box plot? Box plot is based in terms of median and interquartile range. So, this is a one type of say representation of the data, pictorial representation. This is a pre-operative. This is what is called Euroflows. That is this is called Euroflowmetry. Euroflowmetry Qmax milliliter per second data. It's pre-operative. It was median is 6.65 ml per second, and post-operative 25.80 per second. That means highly. That is the Euroflowmetry Qmax value is highly. There is high improvement. Because why there is improvement? Improvement is that the post and pre, but the difference is the median value. The median improvement is on a median is 18.8 ml per second and will 3.75 interquartile. That is interquartile range. So these are non-parametric type of tests, and this test is called, say, Wilcoxon test or Mann-Whitney test. Okay. So now these are paired tests actually. One is called paired test. Paired test means you are taking the same observation, but there are two different time points, one post and pre. That is pre-treatment. You are doing treatment. You are during the admission, you are taking the values of Qmax value, and after treatment, after the surgery, is a one type of surgery. Then some surgery has been done, and after that surgery, post-operative residual value is here. So difference here and p value you see is highly significant. Now E minus 0.7 implies that is 10 to the power minus 7. That means almost less than 0.00001 like that. Now usually the p value less than 0.05 we say it is significant. Now it is more than say less than 0.01 or 0.00001, that also would be highly significant. So this data is highly significant. That means highly, that is there is a treatment effect is due to treatment is highly improvement. There's a significant improvement. You said that we use the term significant. So significant improvement in Qmax value. And so data also post residual volume also data, same thing. This is another parameter post residual. In terms of post residual volume also, there is a 148.12 milliliter and post 41. So post residual volume is decreased. There is a treatment effect. So that is a good sign for that is the outcome of the treatment. So that is also significantly improvement in terms of post-residual volume data. And this also representing the box plot technique. Now for non-parametric data for median interquartile range, we can represent data in terms of box plot. And another term is urethral calibration. These are standard data. Now these are called paired data. Now in every test, like t-test or Wilcoxon test like that, you have to, there's two types of it. One is the normal test, two sample test, normal test, and one is paired test. What is different? Two sample test means two samples are identically distributed. There is no relation between the samples. There is two samples, and one that means that what the two sample means, you are giving drugs to two groups of population and you are comparing the efficacy of the drug. So that is called two samples. There is a two independent population. And
sir, excuse me, Anandamji, can you please make some light over your face, and you can put off your light backside light because face is not visible. So little bit you can raise your voice also. Backlight is disturbing. Put a light on face side.
Is it okay, sir?
Backlight off कर दीजिए.
Backlight off. ठीक है?
Front की on करिए. Yes, this is better. This is better. And volume थोड़ा बढ़ा दीजिए, थोड़ा सा volume. Thank you, sir. Thank you. Thank you.
Achha, so now this is the one type of data analysis. Something like so matched, these are matched data. So paired t-test and normal t. So normal usual two sample t-test means you are comparing the independent populations. That is called two sample t-test, could be two sample Wilcoxon test, and another one is a paired t-test. Paired t-test means a paired Wilcoxon test. That means that from the same observation you are taking data at different time points and you are comparing improvement of the drug, improvement of the treatment, like that. In that is called paired t-test or paired Wilcoxon test, etc. So that should be clear. While for analysis, this should be keep in mind whether I'm comparing to the two populations are independent or dependent. Another thing is that for clinical trials, so patient allocation of patients into different drugs. Suppose there are two groups of patients, there are two treatments, or there are more than two different kinds of treatment. Like say we are saying among AYUSH, so you are telling that for homeopathy, the immunity or like that, or AYUSH versus allopathy treatment, like that. So if you want to compare it, so that means you are allocating patients to different groups. Now, this thing has to be kept in mind that the allocation of patients should be equally at equal. That means two groups, that is patients are in different arms, but the patient should be identical. So identical means the whole patient coming at random, and allocation of patients to different arms or different groups of treatment should be random without any bias. That is the main thing. So how to allocate is, one is simple methods of allocation is that if I assume that the patient coming at a treatment center or healthcare center at random, the patient is coming at random because there is no investigators there is nothing to be done from the investigator side because patient is coming at random. For that case, if I do this like this, for the first patient, you are picking by a random. Suppose there are two arms. There's two groups of patients. Now, first patient, I'm allocating the first patient among one of the two groups. How? Now, based on tossing a coin or based on using random number, etc. So, first patient, suppose there are two groups of patients. The first patient is allocated and in one of the two groups. Then the next patient will be allocated another group. After that, the patient will be allocated in alternative groups. So every alternative patient is allocated in the same group. So if I do like this, that is also quite equal distribution of patients among the two groups. And another thing is that now, what is the utility of this distribution of the patients among the groups is that just a minute. Achha. Alokhi is that, see, there's a one data, this is a visual acuity data. Now there are two groups. Group is the ILA and group is Ojodda. There are two medicine is given to different type groups of patients. Now see that, now these are patient is allocated randomly. That means that without any bias. So that's why, see, age group, how do we have to compare? Now, before starting one trial, we have to compare whether the patients allocated in the different groups are identical in respect of their confounding parameters. That means, what that means, in the, say, for example, in terms of age, you see that these two groups of patients are identical. Because why? Now, these two groups, median value or mean value, these have done non-parametric test, Wilcoxon test. So p-value is significant. Why? Because p-value is more than 0.05. So p-value is more than 0.05 implies that the two groups are identical in respect of age. Though median is varied, because we are median 55 years, median 53 years, but this is happens due to randomness or due to chance factor. There is no causal relationship, or there is no effect, there is no underlying factor. But that means that we can say that there is no, this difference is insignificant. So these two groups are identical with respect to the age, with respect to the sex, because 64% here 46%, and p-value is more than 0.05. So these are six. So these groups are identical. Now I am comparing the visual acuity in terms of this is the calculated in terms of log MAR value, like Snellen log chart. So log MAR value. So lie between. So what is the value? Value, if it is more than, if the value is more close to 0, means high visual acuity is very good, and more to say what the value 1 or more than 1, the visual is worse. So you see that visual acuity baseline here 0.90, median and 0.8 here, and p-value is 0.81. So we have compared the baseline. In terms of baseline visual acuity, these two groups are identical. Now, once I satisfy that in terms of baseline values, the two groups are identical, then I go for comparing. Now, what I've did is the after treatment, we have this a follow-up period. After 1 month, 3 months, 6 months, 9 months, and 12 months. So during this treatment, the drug has been applied, and this what is the drug? This drug is here. Say one is ILA, and there is certain treatment, that is at certain doses, and here to Ojodda also certain doses. Now, so every time point I'm comparing visual acuity after 1 month, after 3 months, after 6 months, after 9 months, after 12 months, and we have observed that visual acuity is, there is no difference in visual acuity. Here, the CMT here, we observe that CMT is here reduced. For some cases, for 1 month and 9 months, that means improvement, etc. Now, another thing is that every drug has a many adverse effect, adverse drug reaction. So we have to keep in mind that we have to study for experimental observations or observational or experimental case anyway. So you have to study adverse drug reaction, sentinel level, serious event, etc. So this thing has to be studied thoroughly. So one of these things here, the intraocular patient is the adverse drug reaction. So it is observed that intraocular patient here does not vary because same, but here intraocular pressure has been increased because 4 by 4 unit. So for this drug, though treatment is same, treatment is improvement is same, but here intraocular pressure is there is a drug adverse drug reaction, intraocular pressure. So IOP has been raised due to the drug. So that means that adverse drug reaction has to be studied. And here adverse ADR also has been studied for around 12 months. So for any study, for clinical trials or the observational study, adverse drug reaction, sentient event, so all these things has to be studied thoroughly. Another thing is that this treatment effect based depends on the medication errors. So usually it is most of the cases is not noted in the hospital administration, hospital case, but medication error is a major point because your efficacy of drug mostly depends on the medication error. And also the adverse drug reaction also happens to be due to medication error. So medication error has to be controlled while studying the drug effect or treatment effect. Now, so everything has been discussed. The cross-sectional, there are the experimental one is the medical research thing. Experimental, you know that experimental data is clinical trials, etc. And another one is the observational. Observational means there's three types: the cross-sectional, then retrospective and prospective. Now, all clinical trials are prospective in nature. What prospective means? You apply a drug, you apply treatment, and observe the patient for a certain time, or follow up the patient for a certain time and observe their development observe the development or effect of the treatment, etc. So these are called prospective data. So prospective data and cross-sectional data means cross-sectional data means taking data at same time point, cause and retrospective means looking at the past. There are three types: retrospective, cross-sectional, and so retrospective, cross-sectional data, and prospective data. Now, experimental data is called clinical trials, phase 1, phase 2, phase 3, single blind, double blind. This is the experimental data. Now, cross-sectional data example is that to find out if there is an association between blood cholesterol level and daily dietary fat intake. So you have to take the relationship, causal relationship between blood cholesterol and daily dietary fat intake. Now here, all these two parameters, you are taking these data from these two parameters from the same patient, but at the same time point. Now take data from at the same time point, duto same time, মানে যখন যাচ্ছি তখন দুটো data নিচ্ছি. Retrospective data কি হচ্ছে? Now retrospective data is that now you are taking the patient lung cancer, you are taking the effect of the lung cancer, smoking in lung cancer. So I am taking the all patient lung cancer patient and then take the question whether they are ex-smoker or they are permanent smoker or the smoker or ex-smoker like that, or no smoker. So we are putting the patient, lung cancer patient in different categories, and then find out whether the smoking is a significant effect on lung cancer or not. So it's a retrospective data. This effect is the lung cancer cause the smoker. So you are looking at the target population with a lung cancer patient, then find out whether they are smoking for the past 5 years or past 10 years or not, like that. This is called, here causality also is not clear. This is a retrospective data, but here prospective, longitudinal prospective data is more accurate data, more reliable data, because here what you do, you take two groups of patients, one smoker and non-smoker, and observe the two group of patients for certain time, and see that how many of these patients have developed lung cancer. And these are called, and in this way you can find out the effect of smoker on lung cancer. Anyway, there is association also could be there. Positive association example is that high blood pressure incident of heart attack, and negative is that screening breast cancer and incident of developing breast cancer. screening and incident of developing breast cancer. This is called negative association. And there's a confounding factor, one is there. In case of correlation, one is, they suppose you can see that there are two variables with high correlation, but this correlation may not be actual due to presence of some other factor. So both calcium deficiency and hip fracture, these are two factors. Now these two factors, calcium deficiency and hip fracture. Now another part is that osteoporosis. Say calcium deficiency, osteoporosis positively associated, and osteoporosis and hip fracture also positively associated. So for studying the association between two variables, we have to be very much clear regarding in respect of confounding variables. So here confounding variables is that calcium deficiency. So determinant and outcomes. You know the correlation and regression, I'm not going to for that. So you know that that's a this thing also has been discussed, like relative risk, odds ratio, and risk differences. Now see that relative risk area, one example is that high blood pressure, present there are two groups of pressure with high blood pressure and normal pressure, and find out the whether developed, what is the risk of determined develops a disease. So 90 by here relative risk could be A by A plus B by C plus C plus D. Here C 3.31 is a relative risk anyway. Now another thing is that while studying relative risk, we have to consider the response variable. Now there are 100 people exposed to risk factor, 20% get the disease. Duto factor, 100 people they were exposed to risk factor, and among 100 people, there 20% of them have developed disease, and there are another 100 people who are not were unexposed. But out of that 100 people, 16% got a disease. And from that, we have to find out what the relative risk factor for that relative risk. That means, so relative risk now 1.25. So what is 1.25 here? This is the formula. A by A plus B by C plus D. That means here 20 by 100 for this first group, and the second group 16 by 100. So if I divide by this, so it will be 20 by 16, so 1.125 relative risk. Now, the main thing is that there is some non-response case. See, so out of 100 people, suppose it happens that 60% of the exposed, they are lost to follow-up. Now, lost to follow-up case is a major thing. Now, 60% of the 100 people who are exposed to the risk factor, they are lost to follow-up. Now, suppose that these 60% among the 60% of the cases, most of them are without a disease. Now, এই যে তোমার 100 জনের মধ্যে কি হচ্ছে, out of 100, 20 হচ্ছে develop a disease, আর rest 80 হচ্ছে not develop a disease. Now, the 60 people, they have lost to follow-up, non-response. Now, this 60 means out of 160. Now, 60 comes from, suppose out remaining 80 who are not exposed. If it happens to be show, then from the data, how many data we have? Now we have data, suppose 20 is that exposed, 20 disease after disease, and suppose and 20 because out of 80, 60 remains non-response. So 20 disease having developed disease and 20 without disease. So naturally, suppose most of the cases of the 60% of the exposed respond to follow-up, all non-responses are from without a disease, then that relative risk will be high, 2.06. So 1.25 take it actual 1.25, but your data will give you 2.06. On the other hand, 60% of the non-exposed is now it's non-exposed type, which is non-exposed, respond, and all non-response are without a disease, then relative risk happens to be lower, 0.75. So a non-response factor is a factor for studying the relative risk. So এটা একটা major thing we have to keep in mind. Now there are different types of technique. So what is this? Now this is called chi-square test. So what is chi-square test? Or just to discuss the reactive risk. Now another thing, logistic regression. There is one thing, regression and logistic regression. What is the difference between regression and logistic regression? Now, regression, the last lecture has been covered, but what is the logistic regression? Now, logistic regression used in case of presence or absence of disease. Suppose, suppose a prevalence of disease, etc. Zero. What is the regression? Regression, the variable y is assumed to be normal distribution, continuous data. So in case of regression, the variable y is assumed to be a continuous, it is a normal distribution. But suppose the value of y is 0 and 1, whether develop the disease or not. Suppose there are certain factors which happens to be that the patient is discharged within a short period of time, or that takes a long time period. Or there are so many factors to determine whether the patient will be in ventilation or not, or the patient will be in ICU or not, or patient recovery rate will be more higher or not. There's so many, that could be so many factors. Or there could be so many factors that the patient is likely to develop a disease or not. So yes or no, in that case, you have to use that case logistic regression. Here, you cannot use a regression technique because regression is why the variable has to be a normal distributed. But here, y is like 0 and 1, like binomial family. So in that case, you have to use logistic regression. There are so many, most of the medical data is logistic regression data. So now this logistic regression technique you have to use, and for that case, logistic regression কি থাকছে না সেটা থাকছে যে ওই relative risk and odds ratio. See here the data. Excellent. See here the logistic regression technique is used to study the MES. MES means major cardiac event. Okay, so it is a cardiac data. So here some technique has been used for angioplasty or like that type, for like angioplasty or so in that this data now. So you have to find out whether the major cardiac event, that is unsuccess. Unsuccess means so like restenosis, etc. is called unsuccessful data. So for this case, now these are the yes or no. That means success or unsuccess. Two types of data, 0 and 1, binary data, and these are the factors. Say rotor burst speed, calcification, age, lesion. So this you have to find out odds ratio in every cases, and p-value here more than 0.05. So that means these are not the factors for this unsuccessful data, unsuccessful event. But here, but this is the data multiple logistic regression technique. So if I combine the data, some of these two, to combine data, rotor bar speed and calcification, in presence of calcification, the rotor bar speed, there is one technique, there is two methods of treatment. The other two methods of treatment, one is that about 18,000 RPM, only 5,000 RPM. So these are two types of treatment, and it is observed that odds ratio is less than 1, the 0.133. So this is a 95 confidence interval, or 0.017 to 0.858, and p-value is less than 0.05. That means that it is a due to a logistic regression. This factor is significant. Whatever is a significant factor for the incident of unsuccessful. That means the second factor is more. Whatever is a factor. So to find out what is the causal factor for an incident, we have to use the logistic regression technique. So there is a logistic regression at another factor. Then the maximum or chi-square test. So chi-square test means this maximum chi-square test means you are taking the observation from the same data, pre and post, like that. This is called pre and post data. Suppose this is a discrete data. Usual chi-square test be independent. Two groups of population are comparing this chi-square data. But maximum chi-square test means the same patient, same group, same people. You are taking the pre-test and post-test data, pre and post, but it is a scoring data. But it is a continuous, discrete data, categorical data. Chi-square test is usually used for categorical data. So suppose you are taking the good, very good, like that. They are taking the two categories, good, very good, like that. So pre-training and post-training. So here, thus we are finding out what is the effect of training, how the training is effective. So it's called McNemar test, chi-square test. These are also mostly used. The other type is the Fisher's exact test. Now, when the data Fisher's exact test, when the suppose for chi-square test, you need to have sample size large enough. But Fisher chi-square test, suppose cell value is less than 5, use the Fisher's chi-square test. And another thing is that I try the Cohen's kappa. Kappa ki hoche? Now, like there are observation, to find out the reliability, validity of the observation, how the observation is consistent. Suppose two groups of inspectors, suppose you are what that means that the main thing is that it is mainly used to find out the measure how your scale is more reliable. That means that you are taking the observations from two different aspects, by Inspector A and Inspector B, and how the decisions are concordant. There is the use of Cohen's kappa. Like it also can be used like thinking like that there are 3 or 4 raters. There are 3 or 4 raters. The performance is given, rating of performance is done by 3 or more than 1 expert. And how the ratings are concordant, how the ratings are more consistent, that is used by Cohen's kappa test. There is another measure mostly used, this Cohen's kappa test. So ANOVA already discussed, and ANOVA, and there is repeated ANOVA. ANOVA underlying assumption is that your data should be normal distributed, because ANOVA means one error part is there. So ANOVA, there is a model for ANOVA involves an error part should be normally distributed. Now suppose the error part is not normal, in that case we can use Kruskal-Wallis test. So non-parametric test is a parametric test for ANOVA, and non-parametric test is Kruskal-Wallis test. Now what is the difference between t-test and ANOVA? Now t-test is used for 2 groups of people. Like suppose there are 2 groups of people, you use t-test, but there are more groups of people, there are more than 2. In that case, you can use ANOVA. 2 treatment effect. Little treatment effect, we can use a t-test. But the more than 2 treatment, we can use ANOVA. That means I am applying 2 types of treatment. We can use the efficacy of the treatment by ANOVA t-test. But if there are more than 2 groups of treatment, like say Unani, homeopathy, allopathy, like that, in that case, we have to use ANOVA. Because if we use t-test, t-test has to be 2 by 2. By ANOVA will determine whether there is significant difference among the group or there is no difference. If it happens to be that is the difference between among the groups, then after that you have to use similar type t-test to find out which groups differ for liking the 2 by 2 comparison. So that means you have a t-test and pair t-test, t-test pair t-test, ANOVA, Kruskal-Wallis test, and t-test হচ্ছে তোমার normal distributed assumption, and when there is no normal assumption, so Wilcoxon Sindak non-parametric test is called Wilcoxon Sindak test and Wilcoxon Samrang test. Achha. Then another thing is that correlation. Now, usually we use the correlation technique, but while using correlation, we have to keep in mind what is the type of data. And if the type of data is say interval scale, in that case you can use Pearson chi-square data. But if the data is called say ordinal data, ordinal means say suppose ranking data like first, second, third, fourth, like that, or say highly satisfied, more so and so, dissatisfied, highly dissatisfied, like that. This is not this type of data is called ordinal data. Now for this type of data, you have to use Spearman's rank correlation coefficient. The Spearman's rank correlation coefficient is that when the data is not an interval, not a ratio scale, so you have to use Spearman rank correlation coefficient. So depending on the nature of the data, we have to adopt a test. You have to find out which test is applicable. So we have to take, there are so many softwares, but to put the data in the software, we have to find out that we have to understand the behavior of the data, the nature of the data. We have to understand the data, what is the interpretation, what is the study sample, and what is the objective of the data, what are objective of the study, and what is the nature of the data. What is that ordinal scale or interval scale, like that? What is the categorical data, or what is the continuous data or discrete data? Whether the data is coming from the same observation, whether the independent observations. Independent means whether patients are independent. I'm taking the data from two independent population or the same population at different time points. So for studying for analysis, you have to keep these many factors. Achha. Achha. Another thing is that, see, so regression is there. Regression you can use, but here one can use Kaplan-Meier estimate. Kaplan-Meier estimate is used into time data. Time data means suppose this data, suppose you are giving a treatment to some people, and or suppose you introducing some like angioplasty or something that, and you have to or stent, and you have to find out what the adverse incident has been occurred or not. So in that case, now it depends on time. It may be that in short period of time there is no adverse incident, but if you observe for a long time of period, so adverse incident may occur at different time points. For that case, we have to use Kaplan-Meier estimate. Kaplan-Meier estimate give you the survival analysis without maze, without survival analysis means survival of the patient without any adverse event. So what different time points? So when you observe the data, survivability on different time or over an extended time, so you can see that this curve is a stepwise curve. So different time survivability ki hocche, different time points ki hocche neme jacche. Because rate of survivability initially is 1, and after that it's called 0.9, like that. So this is called Kaplan-Meier estimate curve. So in that case, this is also another type of data. So, and this data will give you, and in this data, hazard risk or hazard data, this type of data is associated. This is the Kaplan-Meier curve. So hazard ratio is there, and for that case, there is one log score is log rank data. So there is another type of test. See, here Kaplan-Meier curve is called, there is initially 1 and after this 0.7 survival rate. So there is another type of test. These are the logistic regression technique. So logistic regression মানে দুটো হতে পারে, একটা কি হলো আমি একটা পেশেন্টকে অবজার্ভ করলাম and we are giving a treatment to some patient and find out what at a certain time point what we have find out what is that, whether the incident, whether the patient has developed a disease or not, yes or no. That is a logistic regression. And another thing, and another type of thing is that if I introduce time parameter here, the patient has developed a disease, but at what time point? The patient has developed a disease at what time point? Or I'm giving a treatment to some patient whether the death has been occurred due to adverse incident, whether sentient event has been occurred or not. So when sentient event occurred means it may be that instantly, immediately, or in a short time period or a long time period. So in that case, if I, after giving a treatment, if I observe the patient for a long time period, in that case, so time is a factor. So you have to introduce time in the regression. So while using the time point in the regression technique, that is called Kaplan-Meier survival technique, and it is called Cox model, Cox proportional Hash model, and this is called log rank score. There is another type of statistics. So there is so many different types of techniques depending on your criteria, depending on needs and requirements. So how, depending on requirements, you have the data, you have to analyze the data. So two sample interference thing is called hazard risk and fatality model. So there is so many factor analysis is there. Factor analysis means you have to find out which are the major components which are influencing your parameter, like then discriminant analysis. Another thing is that sensitivity and specificity. There is another thing of statistics. So sensitivity and specificity, because suppose like the COVID situation. So COVID situation, RT-PCR test, that is highly sensitive. So there should be gold standard means sensitivity and specificity one actually. But in many cases, it is not possible to adopt the gold standard technique. So there should be a substitute technique, substitute test based on criteria. You have to find out whether the patient has developed disease or not. And accordingly, you have to find out sensitivity and specificity of the test. So, and depending on the criteria, we have to take whether we have to adopt the test, whether with high sensitivity or high specificity. So there is another type of aspect. So there are so many aspects of statistical analysis for this medical data. Okay, thank you. So any questions? Any question? Complete.
Hello, Dr. Pawan Sharma ji. Are you on the platform? So thank you very much, Dr. Arvindam Kunduji. You have very elaborately described the whole of the scenario pertaining to the statistics and especially biostatistics. Though Professor Rajput has not left much area to discuss, but
yes, covered most of the
but very intelligently you traced out the areas which may be given more focused. So your attention and your address was especially regarding the research methodology and where the research methodology takes place in a form of conclusion or inference. That is the total vitality of the data. So the data is so important. Without its filter, without its coverage area, and particularly the scientific approach, which is now been termed by you repeatedly, he touched the diabetes and other diseases pertaining data or symptoms or their parameters. You touched breast cancer, hypertension, and others. The idea is this, that how a researcher belonging to the medical field be able to proceed with the his inputs in a form of the data and filter and categorically decide that what is valuable as a form of the inference. So thank you so much. You did a lot informations available by your long experience, being a senior person and a teacher of your own field. It made very important that how and what the importance and necessity of the biostatistics with a special reference to the its data's value. Thank you so much. Thank you, sir.
Actually, the data has to be there. We have to understand the data. Then, according there is so many techniques. You have to first understand the data, and another thing is that data. One thing is that the collection of data. So all the parameters has to be clearly defined. There is the one.
Very
thing.
correct.
Because
Yeah.
if you suppose the data is collected from different corners, so in that case, the definition should be clearly defined. So if there is a definition is not clear, then the data there is used the noise, the noise that way, it is very difficult to remove the noise. But every term should be clearly defined.
Your state is very clear, sir. But the idea is that what I am feeling ourselves unfortunate that in India, lot of our teaching institutes are there where the persons are the MD scholars are there and they are making their research. Had they been joined, they would have been benefited by all these information. We are hardly in 14 in number. And I saw a few students or a few persons belonging to Uttarakhand Ayurveda University. I do hope that he's been invited by Dr. Rajiv Kurele so that he should get the information that how they have to proceed. So all MD scholars and PhD scholars must be aware by this information, though they can see the YouTube. So thank you again. Thank you so much. And I think since I am continuing as a moderator.
Thank you,
so
thank you, thank you, sir.
Thank you, sir. Yes, sir. You are here. Yes.
Thank you, Kundu-ji. Thank you very much. Thank you very much, Kundu साहेब. आपने बहुत ही मतलब स्पेशलिटी आप दोनों की, राजपूत जी की भी और आपकी कुंडू जी दोनों. We will be troubling you very much in near future also. We will be inviting you for our webinar. Thank you, thank you, thank you.
Actually, sir, the statistics is a huge subject, so it is not possible to cover with a short time period, and that is the main thing. If it is there in a different slots, then I think it will be very easier. It will be very easier.
Very right, you are very right.
So the short time period whole statistics, but it is not. It is very difficult to understand and to interpret everything. That is
yes, yes. So now I would like to request my younger brother, my niece, Dr. Parikshit Devnath. He is GM of Medpharma CRO, MD, MPhil, very brilliant, dynamic expert of Ayurveda and in charge principal of a newly opening Ayurvedic college in Durgapur. Welcome, Dr. Parikshit, welcome.
Thank you, sir, for introducing me. I'm very much humbled that today I will be discussing a sort of conversation related to biostatistics and the importance of biostatistics in AYUSH, the practical aspect of biostatistics in AYUSH. And my previous speakers, they have already highlighted all the aspects which we need to know regarding statistics and biostatistics and implementations in our day-to-day life, like the fields of public health, clinical trials, and other things. So today I will be just touching how can we use the concepts of biostatistics in clinical trials, because in AYUSH fraternity, we are basically using more or less statistics for mainly clinical trials, and these are only used for the clinical trials purpose. And I will be sharing some experiences of mine, because while as a student of postgraduate in MD, I felt the students were not much motivated to learn statistics. They just wanted to mug up the things and anyhow just need to pass the exams. But since I have also done MPhil in public health, and where epidemiology and biostatistics were one of the important subjects. So see, people who come to medical field or any Ayurveda field or Ayush fields, they are very much not liking the fields of mathematics or statistics and everything. But even I also used to do that. But when I started learning statistics, I felt very much encouraged, and it is very interesting. If you see, everything is statistics. What about what everything we say in terms of health science, not only medical, modern medical science or Ayush or anything related to health science or everything in the universe or world, we are just talking about numbers. So suppose we are telling that blood pressure is 120 by 80. That is the standard which is we run as normal. So how that thing, that 120 by 80 millimeter of mercury is the standard blood pressure. This has come from biostatistics. This standardization has come from biostatistics. Like that, all the parameters which we learn while learning medical science, they come from statistics. And these are all child of clinical trials done or medical surveys done. Suppose, how can we say that blood pressure is 120 by 80? Because someone previously have studied apparently normal people, and among thousands and lakhs of people, they have studied and they have found that more or less it's coming around 120 by 80. So this is the average. So how this comes? This is through observations and surveys, which are parts of biostatistics. And already my previous speakers has gone through everything, so I will not be repeating the things which they have discussed. So basically, statistic calculate the p-value, infer a statistically significant relationship between predictor and outcome variables, and calculate the null hypothesis or infer no statistically significant relation between predictor and outcome variables. Now, the thing is that hypothesis testing in basic thing, if we in a clinical trial, if we are basically what they say, comparing two different drugs or a treatment type, suppose A is a standard treatment and B is a new treatment, then the hypothesis will be testing that B is better than A. Our previous speakers has gone through that. But one quotation by Albert Einstein, I will be telling that no amount of experimentation can ever prove me right. A single experiment can prove me wrong. Then there are statistics in there, type 1 error, type 2 errors. One thing is that type 1 errors incorrectly can affect, and type 2 errors will fail to detect a change is there. What conclusion we can bring? That type 1 errors are more serious than type 2 errors when it comes to patients. Then significance level and statistical powers all already have been discussed. The important thing, another, that on which basis we test the significance, it's a called p-value, and basically it's less than 0.05 or 5%. Then there is correlation versus causation. Example correlation I've given, causation is there. Now the important question is, you can perform statistical tests on data that have been collected statistically valid manner, either through experiment and probably the sampling methods. That is the important thing. Sampling method is a very important aspect of statistics and biostatistics related outcomes. And for a statistical test to be valid, sample size needs to be large enough to approximate the true distribution of the population being studied. And the statistical test which we need to do to standardize to get the desired outcome depend on the type of variables. I will not go into details, but during statistical test, we do some assumptions. That is independence of observation, homogeneity of variance, and normality of data. And also, if the previous three assumptions of previous assumptions of normality or homogeneity of variance is not met, then we perform non-parametric test. There are two types of tests, parametric and non-parametric. I am just go over that. The variables which is already discussed, I am not going in details. So while choosing a parametric test, we look for regression, comparison, and correlation. And parametric tests are very stricter requirements than non-parametric, and they make stronger inferences. The most common parametric tests are regression, comparison test, and correlation. There is a table in regression. It can be three types: simple linear, multiple linear, logistic, and on which basis we will be doing the test. They are given predictive variables and outcome variables. Then comparison test look for differences among group means, and among them very important is t-test, ANOVA, and MANOVA. And these are the predictor variables and outcome variables on the test. T-test are two types: paired test and independent. Then ANOVA and MANOVA is there. Then correlation test, we check variables are related or not. That is through Pearson's. Then there is a you can see a flow chart. Then how we can decide which test can be undertaken depending on the data. Then while choosing non-parametric test, they don't make many assumptions about the data and are useful when one or more of the common statistical assumptions are violated. And their inferences are not strong as parametric test. The different parametric test, non-parametric test are Spearman's, chi-square, sign test, Kruskal-Wallis, Anosin, Wilcoxon rank sum test, Wilcoxon sign rank test. So important aspect I will be focusing is the software in biostatistics, used in software, because in previous days people used to do all the calculation through hand and everything, but in present era we are very much, it's a boom that we get softwares to calculate these complex calculations and all these things. So what are the available statistical softwares through which we can do the test and all these things? There are some like Excel, which is very much everybody should be knowing that it's everybody's computer. Excel comes free, and but some higher, if you want to take some higher things, you have to purchase it. And there is another thing, SPSS, Minitab, SAS, LibreOffice, Calc, PSPP, EPI Info. EPI Info is developed by WHO. So it is also a very good software, but normally academia, we try to follow SPSS more. Then see, these are the softwares, use of, see how much the softwares are used according to the analysis of Google Scholar. You can see the most used in SPSS. The golden color you see, the most uses SPSS. In statistics is more or less used, then used in data analysis also you can use SPSS. So these are the some pictures how the data works in Microsoft Excel. Then Microsoft Excel, you have that it's pre-installed in computers. It is very user friendly, and it is good for basic statistics. Someone who is starting to learn statistics, very simple things that can be done through the software. Let's see how these are done. Am I audible? Hello. Yes. So I think my laptop is not working properly.
It's audible, but
I will be talking with you all with my mobile phone, because through mobile connections I will be talking. And another thing is that what is there? Just hold on. LibreOffice Calc. This is another software. Then EPI Info is a software which is used by or which was prepared by WHO, and it's a very efficient software, and it is also used worldwide, and it's a free software. Then it is compatible with Microsoft Office, and it is developed by the CDC, EPI Info. Next is PSPP. It is another software which is used. So what I can, because my laptop is not working at this moment, so I'm giving the speech to my mobile phone. So I can't share at this moment the PPT. So basically what I want to discuss and let the people know that during our studentship, when we are learning postgraduate in MD in Ayurveda, we are not been properly encouraged. And you all know that biostatistics is a very interesting subject. And without biostatistics, clinical trials, any sort of research cannot be done. And whatever the results of the study we get is through biostatistics only. So importance of statistics, without biostatistics, we cannot do any research. Now, what can be done? Because students are not encouraged, and to encourage the students, I feel short-term courses and in biostatistics, especially keeping in mind the clinical trial related aspects of Ayurveda or Ayush stream. Because everybody has discussed on modern pharmacology and other things, but I felt in Ayush or Ayurveda system, we have some different concepts which cannot be dealt in terms of modern medicine. Like more of us are like doing questionnaires are there which are not being standardized. So where biostatistics can help, we have to standardize the questions. There is a term called Cronbach's alpha, through which a questionnaire is standardized, which have qualitative data. And I have seen that in our stream, in previous years, the proper statistical, how to implement the proper statistical test and which test need to be done, these has to be properly imbibed in the minds of the researchers or fellow students. And as a ardent supporter and lover of statistics and biostatistics, I will request that through this forum, which we are doing, we are present today, we can do a CME or on biostatistics, which will be helpful for the students and the researchers. Because what I felt, just 2 or 3 hours of discussion won't help the students that much. They will gather knowledge, they will gather theoretical knowledge, but we need to have a hands-on training on biostatistics. And just leave it, all the complex calculations and everything. People just don't need to do those calculations, complex calculations, because we have the modes of statistical software. So people should know how to use a statistical software. That is very, very much important in present day situation, because no one does complex calculation nowadays. Just we need to know the use of statistical software and the basic thing, where and when to do a statistical test and which statistical test we need to do. And this is very much important. And this is where a biostatistician is more or less needed to decide on the type of variables, on the type of data, which test is the appropriate to get a statistically significant outcome. And by this, I will conclude, because I will not be taking much of your time. But my humble request to everybody, love statistics. It's a very interesting subject. And hopefully in coming days, with permission from Dr. Pawan Sharma sir, we would like to have a hands-on training on biostatistics through this platform. Thank you. Thank you all.
Thank you, Doctor. Thank you very much, Dr. Devnath. Now I would like to hand over the stage to Dr. Agnihotri sir for moderation. Now session is open for discussion. Respected Agnihotri sir.
Thank you, sir. Thank you, Dr. Pawan Sharma ji. Namaskar. Well, thank you very much to Dr. Parikshit Devnath ji. You again touched the rest of the areas where other speakers, guest speakers covered a lot, but still the last sentence of your offer is really a vital one. That is, you are ready to give some training of biostatistics to those persons who are running with their research work, means doing MD or their PhD scholar, because being a MD scholar, your time demerits and crisis is well noticed by you, and you are also facing that now the science and technology has been much more developed, so it will be much more easy to convey your that much of experience in the terms of the short-term training. And if it is happening in a coming webinars, of course, may it be of 1.5 hours or so, then it will go a long way for the students those running with this biostatistical research work and having some sort of crisis. Everywhere the such good knowledgeable persons are not there. They are there from the Ayurvedic field to give the references, to train them. But as far as this biostatistics data filter is concerned, like you told that variables and other data, it is very, very important. This should be used. You have already said probably developed the software of that. So that will also be of great use for those students. So thank you very much. Now, as Dr. Pawan Sharma has told that the platform is open for discussion. So though the number has been reduced to only 12, and the first question raised by our probably, I don't know, she's there, Hema Shetty. She put some questions in the chat box. So if Professor Rajput is there, he may guide her to her queries. We all will be benefited by his intervention. So yeah, I do hope that Professor Rajput is here. Yes, he is here. Professor Rajput, you are invited again to say some words on the question of Dr. Hema Shetty. Namaskar, are you here? Professor Rajput ji? Professor Rajput ji, if you are here, would you like to answer the questions put by Dr. Hema Shetty regarding some research methodology and the sampling and data collection, and also some sort of tests? Some of the questions were answered by our Dr. Sophie ji, Dr. Somani ji. As I told her that she will be giving the answer of her question. Hariom, Dr. Professor S.K. Rajput ji, you are here? I think he is not listening us. So for the intervention of today's webinar's subject, first of all, I would like to get some blessings and some words from Dr. Anand Prakash Pandey ji is very much with us, and Dr. Sophie ji after that. Dr. Anand Prakash Pandey ji, would you like to say something? We invite you on this platform. Dr. Anand Prakash Pandey ji. Hello. Dr. Sophie ji, you are here in our platform. So your important points, we benefited if you intervene some discussion made by our guest speakers. You listened and you remained throughout our whole time webinar. So you please give some blessings and some good wishes to our speakers and also to the platform, that in what way there may be a better approach on our biostatistics in terms of Ayush. Thank you, sir. Namaskar.
Namaskar, sir.
Namaskar.
It was a very nice session for this biostatistics.
Yes.
For those people who are unaware or who just are initiated in this biostatistics,
Yes.
especially when we use it in Ayurveda or traditional medicine. We have learned about the descriptive statistics and inferential statistics. There were several these demonstrations, which test we should use and how we should use it. But some aspects remained there, and there are really those aspects we have to discuss. For example, where we use biostatics in the policy and planning of this Ayush or traditional medicine. And then we have one more this thing, that is decision making. Statistics in decision making, it is very important. And one thing which was talked by the last speaker, it is about the questionnaires, standardization of questionnaires, where we have to use statistics so that these tribal questionnaires will become obsolete, and we will have standard questionnaires if we if we use our statistics in standardizing a questionnaire. Having reliability and validity proved by statistics of the items or questions in the questionnaire, and that will help us to generate a standard tool. That standard tool can be used in research as well as clinical practice also. Say, for example, we have standard questionnaire for Prakriti, or we have standard questionnaire for estimating the dosha, which type of dosha is predominant in a person. Those questionnaires, they need to be standardized, and for standardization, we have to go for biostatistical methods. We have to use them. Similarly, not only that, we have to see this biostats in the perspective that we have to generate concepts, holistic concepts. Those holistic concepts can only be generated if we synthesize various small problems into a whole problem, so that we get the essence of our concepts. If we don't get the essence of our concepts, then it will be just garbage in and garbage out. What we say, we are just using some data and getting some inferences, and then we are saying that, oh, we have validated our concept. It's not like that. Say, for example, if we use factor analysis and seeing that what are the various signs and symptoms which will relate something to dosa or which will relate something to prakriti or mizaj, and we say humors, then if we go for the factor analysis and then make the various domains using statistics, that will be helpful for us. Otherwise, it will be just we are just giving some data to the world and saying that, see the greatness of ours, but basically it is not the greatness of ours, it is the greatness of biostatistics, which allows us to speak the concepts. But we should have the greatness of our concepts, which are just to be made available to the people through biostatistics. It should not be vice versa. I was just studying this, I was just reading about this Kishore Patwardhan's this article. It also came into this The Wire, where he says that principle of falsification should be there so that we make Ayurveda a science. We just are going on validating our concepts. But that is not what proper science says. The proper science says that if we have a theory, it should not be falsified by any one of the experiments. If one experiment falsifies, we have to moderate our theories. Simply, if we go through our historical roots from Charaka and then onwards up to Vagbata, we are seeing there is translation or there is some evolutionary concepts. It is not what Charak said and Vagbata said the same thing. It is evolutionary, and that new things have come up. That was because they have applied their minds so that they have fine-tuned the concepts. Similarly, in Unani medicine, what Hippocrates said, it was preliminary, and what Ibn Sina is saying, it is very much comprehensive. So this evolution of thought, it comes when we analyze things, and this analysis is only possible if we use biostatistical methods for interpreting our concepts. So these were some inputs which I thought that I should add in this discussion. Otherwise, it was very fine and very much needed. This talk was there. Thank you, sir.
Thank you, Professor Sophie, sir. Really, you talked that sector which will guide us to go in a deeper sense as far as the Charak and Bhagavad epics are concerned, because the principles are there and we have to establish and re-establish and revalidate them. So approach maybe as an experiment, but the theme should be protected and it should be reality in a positive manner. You also told otherwise the garbage in and garbage out philosophy will run only. So our students doing MD and PhD, they should be alert enough to see that whatever the project they are taking in the form of the synopsis at the very beginning in the first year itself should be carried out in such a manner that the project be made in principles based on the Arabic text, along with the project in the form of the experimental concept to be related in the revalidation of the concept mentioned in IRES. So thank you so much for your inputs. Your experience spoke by your words. Thank you so much. Now, I would like to have an open call that those who are interested to submit some suggestion or having some questions may come forward to speak something, because today we faced a lot new faces and at the very beginning, but at this time a few remains. So if I start directly naming them, so I may go for the name Dr. Tejinder Singh. He is very much with us and he joined a bit later because he might not be having the exact timing. And since we have gone much more late, it started 8, so the protocol is 8 to 10, it may be 10:15, so it is just 5-6 minutes short to 11. So we would like to sum up as early as possible within 5-10 minutes. So Dr. Tejinder Singh, if you have some words, you can say it to our platform. Dr. Tejendra Singh, are you here? Oh, one new name is also there. That Radhika ji, are you here? And again, this Saida Ashram Firdosh. She also Shaisa Ashma is Firdosh. It's an open call that any person. Yes, Radhika. Yes, you are going to speak some. Yes, invited. Thank you. Namaskar.
Yes, sir. Yes, sir. My name is Radhika. I've been listening to the talk.
Please just give some introduction from where you are talking and what you are doing.
Working at the National Institute of Unani Medicine, sir.
Oh, very good, very good. Okay.
Yeah, it was actually a very good presentation, and it was quite elaborate, sir. The
Thank you.
topics and yeah, actually, I'm lecturer in biostatistics. So
very
that
good.
is so. Yeah,
So you are the right
reason
person to say
that,
something on our today's webinar topic.
yes, exactly, sir. So,
If you have got something new, because
it was quite
what has been told, so if you have got any, something new, you please come.
Yes, sir. Actually, what I would like to tell is that most of the important aspects of biostatistics was being touched upon in this over all the presentations. I have seen that, and where actually there what my experience in this Unani research is very limited, but still I would like to say that. There are many more techniques which we are not actually using it quite well, like advanced statistical methods are not very well used in research related to Ayush, I feel, sir. So I think there is a scope for a lot more of advanced methods and more evidence that can be generated using statistics. So we have to gear up a little bit more and do more studies where we can use such techniques, right? Especially on survival analysis or regression analysis, multivariate regression analysis, such areas, sir. So that is one thing I feel, sir. And I think this discussion is really helpful, and it has made an impact on the participants, especially as a participant point of view. I'm just telling this, sir.
Thank you so much for your participation and for your kind words. Well, today from where you are speaking?
Yes, I am speaking from home, sir. I'm from Bangalore.
You are Bangalore. So you can put your details, your phone number and your email ID in the chat box so that any person you as a teacher would like to contact you in any of the query, you will be able to do that, and that will be there in our records. You are Radhika. So how you inclined to go for Unani medicine? Hello.
Sir, actually, I just started. Hello, can you hear me, sir?
Yeah, a little bit.
Yeah. So it's just been 1 year that I started working with the Unani research. Previously, I was working in medical college, as a lecturer. So so I was teaching biostatistics for the MBBS.
Basically, you are a medical graduate.
No, sir, I'm not a medical graduate. I'm from biostatistics background. I did PG in biostatistics.
You are MSc biostatistics, is it?
Yes, exactly, sir. So I've been working in medical colleges. So,
That's
so
good,
that
so
way I have.
Okay, please.
Yes, sir. So my interest was actually, I was interested in applied statistics right from the beginning of my studies. So that's why I took up this course. Yeah.
Quite fine. Even the medicines belonging to Unani system or Ayurvedic system or Siddha system, basically they are almost one. So that field is very much open for you to go for the statistical studies and make the results available to the coming students. Thank you so much for joining. Thank you. Well,
I will put in my details.
Sure. Thank you for that. Dr. Tejendra Singh. Thank you. Dr. Tejendra Singh, if you are here and want to say something, you can. Or Dr. Parishad ji, if you would like to say some as a feedback, because your tablet, your that laptop was not
Yes,
up to date at that
that I
time.
was
It is
in
better
my
you sum up
so
by a few
just
sentences.
I need to add some points that what happened. I was in my ancestral home, which is far from Kolkata. So the
Okay.
broadband connection was not working properly.
No.
Initially, I have started through my laptop, but at the end it was not working. So I have to go back to the mobile connection, and through mobile I started completing the
Happens, it
thing.
happens.
But in terms of Ayush, what I felt that see, so suppose in clinical trials there are many Ayurvedic terms which are used, suppose for chief complaints. So for a disease, if we are uh, seeing the symptoms and measuring it, how will measure? In Ayurveda, the measuring tools in terms of statistics are not standardized. Like suppose particular disease is severe, very severe, normal, like that. In Ayurveda, we basically put the numbers 1 for severe, 2 for very severe, 3 for very severe. These are the Likert scale. But those questionnaires which we use in the clinical trials or during research, that questionnaires need to be standardized, because without the standardization of the questionnaires, the results are not significant. This is one of the important aspects. Another
Right.
is in Ayurveda, what I have felt that many clinical trials we just do t-test and complete it, and but see, depending on the variable and the data, the uh, outcome is dependent. So what we should keep in mind, what kind of data you are using, and what previously I have told that regarding the questionnaires, we have to standardize the questionnaire, and a question standardization of a questionnaire itself is a research project.
Right.
Every student, if they want to standardize, suppose a quality of life questionnaire which includes the sign symptoms in Ayurvedic terminology, need to be standardized. And for the standardization itself, it's a project. And one important factor for standardization through a statistical inference we do is convex alpha, which I have just mentioned the term. It's a very vast process. So this itself is a project. So what Ayurvedic people should try that for postgraduate or PhD level studies, they can take up one disease if they are developing a questionnaire. So standardizing the questionnaire itself will be a challenge, and it's a project. So these things we can keep in mind. Another, I have already discussed with you, sir, with your blessings. Uh, we'd like to have a hands-on training on statistics with statistical tools. That is the software, use of software. Because at present day, no one does the calculations by hand. Everything is done by the software. So people just need to know how to use the software and what kind of test will be done. That is the basic thing, and that can be trained or taught in a hands-on training program or a CME. This will be also.
Thank you, Dr. Devnas. Really, you again emphasize on the same words that whatever experience with you and whatever knowledge is with you, that will be given only then when the handsome, say 1 week or 1 hour program be available by our channel, by our platform, or by any means, so that really where the need is, that should be needful by your experience and all your knowledge. Thank you so much again for your joining. Thank you so much. Namaskar. If our Dr. Arvind Kundu is here, Arvind is here, he can also give a few line feedback to our platform. Thank you, sir. Namaskar.
Hi, Namaskar, sir.
Okay.
Actually, it's very good, and I liked everyone's talk, and quite informative, well reached. We got also reached with the topics, with the discussions of all the professors, and it is very good and very encouraging this type of sessions.
Sir, if you have gone through the questions of raised by Dr. Shetty, if you like to answer, that it will be in record, so she can visit the YouTube archive. Have you gone?
Person, sir, actually?
Hema Shetty has put some question regarding some test and some sample size or something in the very beginning. She raised the hand, and I advised her to put the question.
Sample regarding sample size.
So this is the right time when you can answer. You both of you can.
Anyway, what question? I cannot. The
question.
Sample size. What was he asking?
I would like to say. See whether the questions are there. Yeah, she wrote one question, sir. Application of multiple ANOVA and repeated measures of ANOVA. If both the group are categorically data like pain assessment in both groups, then which is the test to be applied? Number one question. The second one is hypothesis in research and in testing of data you said are different than in thesis, which should be stated. And the third one, and for all the objectives should be state the hypothesis. So Dr. Sophie has answered that if qualitative data you use non-parametric tests, these were things. Then again she wrote that which non-parametric test should be used instead of repeated measure of ANOVA. So then Dr. Sophie answered that Mann Whitney U test and Kirkshall Walsh test, these two she got it. So if you can add on something, you both have the
actually what I'm saying, ANOVA is done for when the errors are normally distributed, but in many cases the errors are not normally distributed. In that case, when we don't have any data distribution, we go for non-parametric test. Like say t-test, there's no distribution, we go for manual t-test or Wilcoxon sign that test like that. So similarly, so actually ANOVA is a ANOVA is for more than 2 cases. We use, instead of t-test, we use ANOVA. Similar cases, so T is replaced by say manual t-test. Similar to ANOVA is replaced by Kruskal-Wallis test. Kruskal-Wallis test is for data where the errors part is not, there is no distribution. We do not know the distribution of the error part. We go for Kruskal-Wallis test. So
thank you, sir. Thank you. Because these questions were addressed to Professor Rajput, as he is not here available. So whenever she will visit the YouTube archive, she may get the answer. Dr. Devnath, sir, if you like to add on something, or the answer is sufficient.
Sir, today's program was very good for an introductory aspect, but see, many queries can only be given answered when we do have a practical aspect, when you have a put on a data and what kind of statistics softwares are you using. That will be a very easier to people know how to approach everything. And just a single session is very small, because biostatistics is a very vast subject. And sorry, with respect to all the teachers there, and that it cannot be completed in a 2-hour session, because one topic can take a single day to learn.
Thank you, sir. Thank you. And sorry to say that I could not take out the details of as introduction, that what Hema Shetty is doing, whether she is a lecturer, reader, or student, or MD scholar. So that as you told, that introductory level, she may be, the question might be belong to the introductory level. Yes, so in that way, this may be the question from her side.
Yes, sir. But the statistics should be understood. With the previous speakers who are before me, they were just like Kundu sir. He is a statistician, and for a statistician, it's easy to understand statistics and let people know. But from persons like us who are from medical background and
exactly, this is the point.
The toughest thing, not the toughest thing. We have to learn love statistics. If you love statistics, it will be easier.
You people can put the vitality with the special reference to the diseases and the symptoms and the patients in the terms of the biostatistics, right, sir? You touched that very point which she might be interested of. Yeah, yes, sir.
So one thing there, this can be understood more easily when given the data.
Right.
Yes, sir.
Based on this,
now you both are, now the amalgamated form of both of you person might have sufficed the purpose and the basic theme of that question. Though neither she is available, nor Professor Rajput is available, but the archive will do the same. Thank you so much for joining to all, because we are all getting very, very late. I am really thankful for your participation, that to this extent, even after completing your own lectures. So thank you so much as a guest speakers. And I see that Madam Momita Sharma is always there throughout the webinar, but it is very hard to have any sentence from her. If she would like to say either closing words for today's webinar, it will be our webinar's pleasure. Otherwise, I will just return to the platform to our Dr. Pawan Sharma ji. Yes, Dr. Pawan Sharma ji, if you are available, that now the platform is belonging to you again. So thank you all, to all our guest speakers, to all our participants, those who ornamented today's webinar. Dr. Sharma ji, you are here? Or he has taken leave? Then I would like to...
Sir, then on behalf of Dr. Sharma, I will thank all the participants, and I can promise that in coming days we will have a good session on biostatistics and its practical application. Okay, Devna sir, as you are the co-host, so I would just like to thank to all our participants in our formal thank-giving program in a form of concluding remarks. So right from Dr. Rajiv Kurele, who introduced our today's guest speakers like Professor Rajput ji, I just give some words to those who have joined a new person, not the new faces, because the faces are not seen, but the names are seen. So in that way, our Professor, right from our Professor Guruji, Professor C. Vijay sir, Dr. Pawan Kumar Sharma ji, Dr. Hema Shetty, Dr. Rampal Somani ji, Dr. Sophie ji, Dr. Sunaina Arya, Vaidya Parul ji, Miss Momita Sharma ji, Dr. Shreya Goyal ji, Dr. Bharat Chongde ji, Dr. Tejinder Singh ji, Miss Kiran Jha ji, and Miss Mohammad Zamullah sir, or Miss Pratibha Jha ji, Miss Radhika ji, Dr. Anand Prakash Pandey ji, and Saida Azma Firdaus. These all are our present in our platform today, and we were 21 in number in very beginning. So I extend our thanks to all our guest speakers, right from Professor S.K. Ravasa, Professor Dr. Rajiv Kurele ji, Dr. Pekshit Devna sir, and our Kundu sir. So with these few words, I thank you all. I say goodbye, good namaskar, good night, and over to Devna sir just to make the closing. Thank you, sir. Thank you. Namaskar.
Thank you, sir.
Thank you, everybody. Thank you for your presence. Have a nice day. Good night.
Good night. Good night. Thank you.